The most powerful evidence that humans walked on the moon comes from the one source conspiracy theorists never mention. The Soviet Union acknowledged it happened. This single fact demolishes every moon landing hoax theory ever constructed, yet it remains almost completely ignored in conspiracy circles. Understanding why requires examining the most intense geopolitical rivalry in human history and recognizing what Soviet silence actually means. In 1969, the United States and Soviet Union were locked in ideological warfare that touched every corner of human civilization. The Cold War defined global politics, military strategy, economic systems, and the future direction of humanity itself. These two superpowers competed for influence across every continent, stockpiled enough nuclear weapons to destroy civilization multiple times over, and fought proxy wars from Southeast Asia to Africa to Latin America. Billions of dollars flowed into intelligence operations designed to expose, undermine, and discredit the opposing system. The Soviet Union maintained one of history's most sophisticated propaganda machines, actively promoting conspiracy theories about everything from the John F. Kennedy assassination to alleged American biological warfare programs. Their media apparatus reached hundreds of millions of people globally, spreading narratives designed to damage Western credibility and advance Soviet strategic interests. Space exploration became the ultimate arena for this competition. When Soviet cosmonaut Yuri Gagarin became the first human in space on April 12, 1961, the propaganda value was immeasurable. The achievement demonstrated Soviet technological superiority, validated their political system, and horrified American leadership. President Kennedy's response came 3 weeks later when he stood before Congress and committed the United States to landing a man on the moon before the decade's end. This was not merely an exploration goal. This was a direct challenge to Soviet dominance, a public declaration that America would surpass them in the most visible, most prestigious arena of technological competition imaginable. The stakes were absolute. Failure would mean global humiliation. Success would prove which system, capitalism or communism, represented humanity's future. Both nations poured enormous resources into their space programs. Thousands of engineers, billions of dollars, and national prestige rested on beating the other side. The Soviets maintained early dominance with a series of firsts, including the first satellite, first animal in space, first human in space, first woman in space, first spacewalk, and first probe to impact the moon. American engineers scrambled to catch up, learning from failures, refining technology, and building the massive infrastructure required for lunar missions. By 1968, the race reached its climax. The Soviets were developing their N-1 rocket, a colossal launch vehicle designed to send cosmonauts to the lunar surface. American intelligence tracked Soviet progress with increasing alarm. CIA analysts studied satellite photographs of the Baikonur Cosmodrome, identifying launch facilities under construction. The question was not whether the Soviets were attempting to reach the moon, but whether they would succeed first. NASA accelerated its timeline, taking risks that made engineers uncomfortable but seemed necessary to win. Apollo 8's circumlunar mission in December 1968 shocked the world. Frank Borman, James Lovell, and William Anders became the first humans to leave Earth's gravitational influence, orbit another celestial body, and return home. The mission was audacious, flying hardware that had never been tested in space to a destination 250,000 miles away. Soviet leadership watched with growing concern as America demonstrated capabilities they were still developing. The propaganda impact was enormous. The crew's Christmas Eve broadcast, where they read from Genesis while showing Earth rising above the lunar horizon, reached the largest television audience in history at that time. 5 months later, Apollo 10 performed a full dress rehearsal, descending to within 15,000 meters of the lunar surface. Tom Stafford, John Young, and Eugene Cernan tested every system, procedure, and maneuver required for landing, except the final touchdown itself. They proved the lunar module could separate, descend, hover, and return to orbit successfully. They demonstrated that astronauts could navigate in lunar orbit, identify landing sites, and execute precision maneuvers. Soviet engineers tracking these missions realized with growing certainty that Apollo would attempt landing soon and likely succeed. This brings us to the central question. If Apollo 11 was fake, if Neil Armstrong and Buzz Aldrin never walked on the moon, if the entire spectacle was staged in a studio somewhere, why did the Soviet Union stay silent? They had every possible motive to expose American fraud. They possessed sophisticated tracking capabilities, able to monitor every aspect of the mission from launch to splashdown. They operated a global network of radar installations, radio telescopes, and intelligence-gathering stations specifically designed to surveil American space activities. They employed thousands of scientists, engineers, and analysts whose careers focused on understanding and countering American technological developments. The propaganda value of exposing a hoax would have been incalculable. Imagine the global reaction if Moscow had presented evidence proving America faked the moon landing. The humiliation would have destroyed American credibility permanently. Every ally would have questioned their relationship with Washington. Every treaty, agreement, and diplomatic commitment would have been suspect. The Soviet Union would have won the Cold War's most important propaganda victory without firing a shot. Their political system would have been vindicated as the truthful alternative to deceitful capitalism. The exposure would have justified decades of Soviet criticism about American imperialism, dishonesty, and moral bankruptcy. Yet Soviet leadership did the opposite. They congratulated NASA. They acknowledged the landing in official statements. They tracked the mission with their Space Transmissions Corps and confirmed what American controllers were saying. Soviet scientists called it an outstanding achievement. Soviet Premier Alexei Kosygin sent congratulatory telegrams. Pravda, the Communist Party newspaper, ran front-page coverage showing American astronauts on the lunar surface. Moscow radio led broadcasts with Apollo news. The Soviet Academy of Sciences president praised the accomplishment. Cosmonauts sent congratulations to the Apollo crew. This response is completely incompatible with the hoax theory. Consider what conspiracy theorists are actually claiming. They argue that NASA staged an elaborate deception involving thousands of people across multiple agencies, facilities, and countries. They claim television broadcasts were pre-recorded studio productions. They insist radio transmissions were faked from Earth-based transmitters. They suggest photographs were taken in studios with artificial lighting. They propose that hundreds of thousands of people, from astronauts to engineers to technicians to tracking station operators, all participated in or were fooled by this deception. For this to work, the Soviet Union would need to be complicit or incompetent. Complicity is absurd. Why would America's greatest enemy, locked in existential ideological struggle, agree to validate a propaganda victory that would damage Soviet prestige and strengthen American influence globally? What could possibly motivate Soviet leadership to participate in or ignore evidence of such fraud? Some conspiracy theorists propose that America traded wheat shipments for Soviet silence, an explanation that collapses under minimal scrutiny. The Soviet Union suffered genuine food shortages in the early 1970s. These shortages were public, embarrassing, and politically dangerous for Soviet leadership. Accepting grain in exchange for covering up the century's greatest deception would have been exponentially more damaging than admitting their space program failed to reach the moon first. The political cost of complicity would far outweigh any benefit from grain imports. The incompetence explanation fails equally. Soviet space tracking capabilities were formidable. They had been monitoring American launches since Explorer 1 in 1958. Their radar stations tracked trajectories, velocities, and orbital parameters with high precision. Their signals intelligence operations intercepted and analyzed American communications continuously. They employed some of the world's best scientists and engineers. People who understood orbital mechanics, radio propagation, and spacecraft systems at expert levels. The idea that Soviet intelligence simply missed evidence of fakery or lacked capability to detect it contradicts everything we know about their technical capabilities and intelligence operations during this period. The Soviet silence is not mysterious when you accept the obvious conclusion. Apollo happened. Armstrong and Aldrin walked on the moon. The Soviet Union knew it was real because they tracked the entire mission with their own independent systems. They acknowledged it because denying obvious reality would have made them appear delusional and destroyed their own credibility. Even in the midst of Cold War competition, Soviet leadership recognized that falsely accusing America of fraud without evidence would backfire catastrophically. Truth mattered, even to adversaries, because international credibility depended on it. What happened in Moscow during those July days in 1969 reveals the human dimension of this geopolitical drama. Soviet leadership had invested enormous resources and prestige in beating America to the moon. Their lunar program, hidden from the world, had failed catastrophically in ways we will explore. They watched Apollo 11's progress, knowing their own chance for victory had passed. The American success was simultaneously a technological triumph they could appreciate as engineers and scientists, and a devastating political defeat that undermined Soviet claims of superiority. How they responded to this contradiction tells us everything about why the hoax theory fails. The next chapter takes us inside the Kremlin as Apollo 11 descended toward the lunar surface. Chapter 2, July 20th, 1969, Inside the Kremlin. Moscow operated 9 hours ahead of Houston. When Apollo 11 separated its lunar module from the command module on July 20th at 2 p.m. Eastern Time, it was 11 p.m. in the Soviet capital. By the time Eagle began its powered descent toward the Sea of Tranquility at 3:08 p.m. Houston time, midnight had passed in Moscow and a new day had begun. Soviet leadership did not sleep. They monitored developments through the night, receiving updates from their Space Transmissions Corps, watching as America attempted what their own program had failed to achieve. The Soviet government maintained strict control over information. Television and radio broadcasts followed government directives. Newspapers printed what censors approved. The population received carefully curated news designed to support state narratives and minimize Western achievements. How Moscow chose to present Apollo 11 would reveal their true assessment of the mission's authenticity. If they suspected fraud, this was the moment to plant seeds of doubt, to question American claims, to suggest technical impossibilities. Instead, they did something remarkable for a totalitarian state during the Cold War's peak. They told their people the truth. Moscow radio led its morning broadcast with news of the moon landing. The state-controlled broadcaster, which reached millions of Soviet citizens and served as an official voice of government policy, announced that American astronauts had successfully reached the lunar surface. This was not buried in minor coverage. This was headline news, presented as a significant achievement. The decision to lead with this story, rather than downplaying it or ignoring it, signaled official acknowledgement at the highest levels of government. Pravda, the Communist Party's official newspaper and the most important print publication in the Soviet Union, made an even more dramatic gesture. The July 21st edition featured the moon landing on its front page with a prominent headline reading, "They have mooned." Pravda's front page was sacred real estate, reserved for stories advancing Soviet interests and communist ideology. Giving this space to an American achievement was extraordinary. The layout itself told a story. The report about Luna 15, the unmanned Soviet spacecraft then orbiting the moon, occupied the top position on the page. The Apollo coverage appeared below it. This positioning allowed Soviet editors to maintain some pride, suggesting their mission held equal or greater importance, while still acknowledging American success prominently. The Pravda article's language is revealing. Rather than hostile or skeptical, the coverage was factual and even admiring in places. The newspaper captioned a photograph of the Apollo 11 crew as these three courageous men. This descriptor, courageous, appeared in the Soviet Union's most important newspaper, describing American astronauts during the Cold War's most intense competition. Courage was a quality Soviets valued deeply, tied to their historical narrative of defeating Nazi Germany through sacrifice and bravery. Applying this term to American rivals demonstrated genuine respect, an acknowledgement that whatever political differences existed, the human achievement deserved recognition. Izvestia, another major Soviet newspaper, similarly ran the landing story on its first page. Multiple official publications made the same editorial decision, suggesting coordinated government policy rather than independent journalism. Someone at high levels of Soviet government decided that acknowledging Apollo openly served Soviet interests better than denial or silence. This calculation reveals sophisticated strategic thinking. Denying obvious reality would make the Soviet Union appear disconnected from facts, undermining their credibility in other contexts. Acknowledging a genuine achievement while emphasizing their own space program's continuing importance allowed them to maintain dignity while accepting temporary defeat. Soviet television audiences saw something unprecedented. State television broadcast footage of the lunar surface walk 3 separate times. Each broadcast reached millions of viewers who watched American astronauts bouncing across an alien landscape. The video quality was poor, transmitted from across space and filtered through atmospheric interference, but the images were unmistakable. 2 human figures in bulky white suits moved against a gray landscape with black sky. The lunar module sat in the background, its gold foil exterior reflecting sunlight. American flags and voices accompanied the footage, leaving no doubt about who had accomplished this feat. Broadcasting this footage 3 times was a deliberate choice. Once might be dismissed as grudging acknowledgement. 3 times indicated something different. Soviet viewers could watch the entire event unfold, see extended coverage, and draw their own conclusions. The government was not hiding American success. They were presenting it repeatedly to their population. This openness contradicts the conspiracy theory's requirements. If Apollo was fake, if the footage came from studios and the whole event was theater, Soviet intelligence would have known. They would have evidence. Broadcasting obvious fraud to your population while possessing proof of deception makes no sense. Broadcasting real footage of a genuine achievement, even when it helps your adversary, makes sense if maintaining credibility matters more than short-term embarrassment. Soviet scientists provided public commentary that went further than official acknowledgement. Konstantin Fektistov, a Soviet cosmonaut and spacecraft designer who had flown on Voskhod 1, called Apollo 11 an outstanding achievement. These words came from someone who understood spacecraft systems intimately, who had experienced space travel personally, and who competed directly with American astronauts. His professional assessment carried weight within the Soviet scientific community and internationally. Georgy Petrov, another prominent Soviet scientist, described the landing as a major landmark in space exploration. These were not grudging admissions. These were professional recognitions from experts who appreciated the technical complexity of what NASA had accomplished. American tourists in Moscow reported surprising reactions from Soviet citizens. Outside the National Hotel, which overlooked the Kremlin, Soviet teenagers approached Americans to extend congratulations. This spontaneous public response suggests the official acknowledgement had filtered through society. Young people, often most skeptical of government narratives, accepted that the landing was real and felt moved to congratulate nationals of the country that achieved it. The United States Embassy received numerous inquiries from Russians, Americans, and others seeking details about the moon landing. People wanted information, wanting to understand how the mission worked and what it meant. This genuine public interest contrasts sharply with the conspiracy theory's implication that everyone involved or watching should have been suspicious. The highest levels of Soviet government participated in this acknowledgement. Premier Alexei Kosygin, chairman of the Council of Ministers and one of the Soviet Union's most powerful officials, sent a congratulatory message that was relayed to the astronauts while they were still on the lunar surface. Imagine that moment. Neil Armstrong and Buzz Aldrin, standing inside the lunar module after their historic moonwalk, received a message from the leader of America's greatest adversary, congratulating them on their achievement. Houston relayed Kosygin's words through space to the moon. The Soviet premier's congratulations were official, public, and recorded in the mission transcripts. This was not private communication that could be denied later. This was formal diplomatic acknowledgement transmitted through official channels and documented in multiple records. Kosygin's action requires explanation under the hoax theory. Why would the Soviet premier congratulate astronauts for something fake? What motivation could exist for validating American deception at the highest official level? The conspiracy theorist must propose that Kosygin was fooled or complicit or playing some deeper game. Each option fails. Kosygin was not stupid. He had access to the Soviet Union's entire intelligence apparatus. He could consult with the country's best scientists and engineers. He would have been briefed on what Soviet tracking stations were observing. If those tracking stations detected anything suspicious, anything suggesting Apollo 11 was not where NASA claimed, that information would have reached Kosygin's desk immediately. The official Soviet response was coordinated across multiple channels simultaneously. Radio broadcasts, television coverage, newspaper front pages, scientific commentary, diplomatic messages, and public acknowledgement all aligned within hours. This coordination indicates decision-making at the highest levels, probably involving Premier Kosygin, Party Secretary Leonid Brezhnev, and key advisors. They chose acknowledgement over denial, truth over propaganda advantage. This choice reveals their assessment of the evidence. If they had any doubt about Apollo's authenticity, they would have hedged, using careful language that avoided confirming or denying. Instead, they confirmed emphatically through multiple official channels. Soviet cosmonauts added their voices to this chorus of acknowledgement. These were not bureaucrats or propagandists. These were test pilots and engineers who had flown in space themselves, who understood the risks and challenges intimately. They sent congratulatory messages to the Apollo crew, professional recognition between spacefarers who shared a unique experience. Alexei Leonov, who had performed the first spacewalk in 1965, later spoke about Apollo missions with admiration and detailed technical knowledge. Georgy Grechko, another Soviet cosmonaut, discussed Apollo extensively in memoirs and interviews, never questioning its authenticity. The cosmonaut core acceptance of Apollo as genuine carries enormous weight. These individuals had no reason to validate American success if evidence suggested fraud. One curious detail from this period deserves attention. Lieutenant General Nikolai Kamenin, who oversaw cosmonaut training and selection, kept detailed diaries documenting Soviet space program developments. His entries provide rare insights into official thinking and internal reactions. Kamenin's diary contains a suspicious gap from July 7th to August 20th, 1969, covering the entire period of Apollo 11 and immediate aftermath. This 44-day gap is the longest in his otherwise meticulous record-keeping. Some researchers suggest this indicates the period's sensitivity, that discussions and decisions made during these weeks were so politically delicate that Kamenin chose not to document them, or that his documentation was removed later. What might those missing entries have contained? Probably frank assessments of the Apollo mission, discussions of Soviet program failures, and leadership debates about how to respond publicly. The gap itself suggests how painful this period was for Soviet space officials. They had dedicated careers to beating America to the moon. They had designed hardware, trained cosmonauts, and prepared for missions that would never fly. Watching Apollo succeed while their N-1 rocket sat as a twisted wreck at Baikonur Cosmodrome must have been agonizing. Kamenin's silence during these weeks speaks to emotional and professional trauma, not to doubts about Apollo's reality. The Soviet Academy of Sciences, the country's premier scientific institution, issued its own statement through President Mstislav Keldysh. Keldysh was not a minor figure. He was one of the Soviet Union's leading mathematicians and space program architects, deeply involved in mission planning and spacecraft design. His scientific credentials were impeccable, his understanding of space technology comprehensive. Keldysh praised the Apollo achievement publicly, calling it a significant step for humanity. These words came from someone who could have questioned technical details if any seemed doubtful. His endorsement carried weight within the international scientific community and within Soviet government circles. The coordinated Soviet response in July 1969 established a pattern that would continue through subsequent Apollo missions. Each landing received official acknowledgement, media coverage, and scientific recognition. The Soviet government never wavered from this position. They never suggested doubt, never questioned evidence, never proposed alternative explanations. This consistency across years and multiple missions indicates genuine acceptance, not temporary political calculation. They acknowledged Apollo because their tracking data, their scientific analysis, and their intelligence reporting all confirmed the same conclusion. Americans had reached the moon. Denying it would have been lying, and lies are fragile when truth can be independently verified. What the Soviets knew and how they knew it becomes the next chapter's focus. Their tracking capabilities were extensive, their surveillance sophisticated, and their ability to verify American claims independently robust. Understanding what Soviet eyes and ears observed during Apollo missions reveals why denial was never a realistic option. The technology of verification made silence the only credible response. Chapter 3: The space transmissions caught Soviet eyes in the sky. The Soviet Union did not trust American announcements about space achievements. They verified independently using one of the Cold War's most sophisticated surveillance networks. The Space Transmissions Corps represented the Soviet military's dedicated space tracking and intelligence-gathering organization, fully equipped with cutting-edge technology designed specifically to monitor, intercept, and analyze every aspect of foreign space activities. This was not casual observation. This was professional military intelligence work conducted by trained specialists using equipment that represented the Soviet Union's best surveillance technology. The Space Transmissions Corps operated facilities across the Soviet Union and aligned nations, creating a global network capable of tracking spacecraft from any location on Earth. Major installations existed at Yevpatoria in Crimea, Ushariysk in the Far East, and multiple sites across Soviet territory. These installations featured massive radio telescopes, sensitive receivers capable of detecting faint signals from deep space, and sophisticated analysis equipment for processing intercepted communications. The network was designed with redundancy, ensuring multiple stations could track significant missions simultaneously. This eliminated the possibility of missing critical data due to equipment failure or geographic limitations. When Apollo missions launched from Cape Canaveral in Florida, Soviet radar detected them immediately. The act of launching created radar signatures impossible to hide. The Saturn V rocket, standing 110 meters tall and weighing approximately 3,000 metric tons fully fueled, produced an enormous radar cross-section. Its engines generated thrust levels exceeding 34 million newtons at liftoff, creating acoustic and thermal signatures detectable by multiple sensor types. Soviet radar installations tracked the ascent trajectory, calculating velocity, altitude, and heading in real time. Within minutes of liftoff, Soviet controllers knew Apollo was flying, where it was going, and how fast it was traveling. This tracking continued throughout Earth orbit, translunar injection, and the entire journey to the moon. The physics of spacecraft trajectory are unforgiving. A vehicle traveling from Earth to the moon follows predictable paths determined by gravitational forces, velocity, and departure angles. Soviet tracking stations measured Apollo's position repeatedly, comparing observations against predicted trajectories. Any discrepancy between claimed position and observed position would have been obvious immediately. If Apollo 11 was not actually traveling to the moon, but remained in Earth orbit or on the ground, Soviet radar would have detected this instantly. The spacecraft's radio transmissions came from specific locations in space, locations that moved in ways consistent with lunar trajectory or inconsistent with it. Radio interception provided even richer intelligence. Apollo spacecraft transmitted continuously on multiple frequencies, sending telemetry data to Houston, voice communications between astronauts and mission control, and television signals during specific mission phases. Soviet receivers tuned to these frequencies captured everything. The Space Transmissions Corps employed specialists who understood NASA communication protocols, spacecraft systems, and mission procedures. They listened to astronaut conversations, decoded telemetry data, and analyzed the information flow between spacecraft and ground stations. These intercepts could not be faked in ways that that would fool Soviet analysts. Radio transmissions carry specific characteristics based on their origin point. Signals from the moon arrive with time delays matching the distance, approximately 1.3 seconds for radio waves to travel from lunar surface to Earth. Doppler shift in frequencies reveals relative motion between transmitter and receiver. As Apollo spacecraft traveled toward the moon, their radio signals showed Doppler shifts consistent with recession velocity. As they orbited the moon, signals showed periodic Doppler patterns matching orbital mechanics. Faking these characteristics from Earth-based transmitters would require perfectly replicating the physics of space-based transmission, including time delays, Doppler effects, and signal strength variations. The technical challenge of creating such deception would exceed the challenge of actually flying to the moon. Third-party verification added additional layers of confirmation. The Soviet Union was not the only nation monitoring Apollo. The Jodrell Bank Observatory in the United Kingdom operated one of the world's largest radio telescopes, the 76-meter Lovell telescope. This facility tracked Apollo missions independently, motivated by scientific interest rather than military intelligence. During Apollo 11, Jodrell Bank scientists pointed their telescope toward the moon and received transmissions directly from the lunar module. They heard Neil Armstrong and Buzz Aldrin's voices as astronauts communicated with Houston. They intercepted television signals showing images from the lunar surface. These intercepts were independent of NASA, processed by British scientists who had no reason to participate in American deception. Jodrell Bank's most dramatic contribution came from tracking Luna 15 simultaneously with Apollo 11. The Soviet Union had launched this unmanned probe 3 days before Apollo 11 departed Earth, attempting an automated sample return mission that might salvage propaganda value if it succeeded before Apollo landed. Jodrell Bank tracked both spacecraft, monitoring Luna 15's orbit around the moon, while also receiving signals from Eagle as it descended to the surface. Sir Bernard Lovell, Jodrell Bank's director, recorded audio commentary during these events. His recordings capture real-time observations of both missions, including the moment Luna 15 crashed into the moon's surface on July 21st, just hours before Armstrong and Aldrin lifted off to rejoin Michael Collins in lunar orbit. These Jodrell Bank observations were public. The British scientists published their findings, discussed them with media, and shared data with the international scientific community. They confirmed Apollo's trajectory, verified its lunar orbit, and authenticated transmissions from the surface. Soviet intelligence would have been aware of this independent verification. They would have known that multiple nations with sophisticated tracking capabilities were observing the same events their Space Transmissions Corps was monitoring. Claiming Apollo was fake would mean contradicting not just American statements, but also British observations, plus tracking data from Australia, Spain, and other countries hosting NASA Deep Space Network stations. The Bochum Observatory in Germany provided another independent verification. This facility intercepted television signals from Apollo 16 in 1972, recording them directly from lunar transmissions. The Germans received video showing astronauts on the lunar surface without any intermediate routing through Houston. The transmissions originated from the moon itself, traveled through space, and arrived at German receivers. The observatory still maintains these videotapes in storage, physical evidence of direct reception from an Apollo spacecraft during surface operations. Faking such transmissions would require transmitting from the moon, which defeats the entire purpose of the hoax theory. Soviet tracking of earlier missions established patterns that made Apollo 11 verification straightforward. The Space Transmissions Corps had monitored Apollo 8's circumlunar flight in December 1968, tracking the spacecraft as it left Earth orbit, traveled to the moon, executed lunar orbit insertion, and returned home. They tracked Apollo 10's dress rehearsal in May 1969, monitoring the lunar module's descent to within 15 kilometers of the surface. Each mission provided data points confirming NASA's capabilities and mission profiles. By July 1969, Soviet analysts had months of tracking data showing that Apollo spacecraft performed as NASA described. Questioning Apollo 11 would require explaining why this mission suddenly involved deception when previous missions had been genuine. The technical specifications of Soviet tracking equipment guaranteed detection capability. Deep space tracking facilities introduced at Ushariysk and Yevpatoria in 1962 had ranges exceeding 100 million kilometers, far beyond the Earth-Moon distance of roughly 380,000 kilometers. These stations could track Soviet Venera probes traveling to Venus and detect their faint signals across tens of millions of kilometers of space. Tracking a spacecraft at lunar distances was trivial by comparison. The systems were sensitive enough to detect low-power transmitters on the lunar surface, as demonstrated when Soviet RETAN 600 radio telescope observed Apollo lunar surface experiments package transmitters in 1977. These scientific packages, left behind by Apollo crews, broadcast at only 20 watts power. Soviet instruments detected them years after astronauts had departed, confirming their locations matched NASA reports exactly. The Apollo mission's radio communications were continuous and detailed. Astronauts maintained near constant communication with Houston during critical mission phases, describing what they saw, reporting instrument readings, and executing procedures called out by controllers. These conversations lasted hours, filled with technical detail, casual comments, unexpected observations, and real-time problem solving. Faking such communications would require scripts of unprecedented complexity, actors with perfect technical knowledge, and absolutely no errors across multiple missions, totaling hundreds of hours of air time. Soviet analysts listening to these transmissions would detect inconsistencies, technical errors, or suspicious patterns if the communications were scripted rather than genuine. One specific example illustrates the communication's authenticity. During Apollo 11's landing, the lunar module's guidance computer generated a series of program alarms, indicating it was overloaded with data processing. These alarms, designated 1201 and 1202, were not planned. They created tension in mission control as controllers debated whether to abort the landing. The conversation between Eagle and Houston regarding these alarms was unscripted, filled with the uncertainty of real-time decision-making. Engineers in the mission operations control room consulted with the guidance officer, who determined the alarms were not critical. They told Armstrong to continue. This entire sequence, lasting several minutes, showed the spontaneity of genuine spaceflight. Scripting such a scene with perfect technical accuracy while maintaining dramatic tension would be remarkably difficult. Soviet analysts listening in real time would recognize the interaction as authentic problem-solving rather than staged performance. The lunar module's descent itself provided continuous verification through multiple channels. Radar altimeter data showed decreasing altitude as Eagle approached the surface. Voice communications described the view from the windows, with Armstrong calling out crater references that matched lunar maps. Telemetry transmitted to Houston and intercepted by Soviet receivers showed engine thrust levels, fuel consumption, attitude changes, and velocity decrements consistent with powered descent. The spacecraft's mass decreased as fuel burned, affecting its response to control inputs in ways that matched physics. Every data stream told the same story: a spacecraft descending to a lunar landing. Faking all these correlated data streams simultaneously from Earth would require technology and coordination beyond 1969 capabilities. The visual evidence presented additional verification challenges for any hoax scenario. Apollo missions returned photographs showing lunar landscapes, Earth rising over the Moon's horizon, and astronauts working on the surface. These photographs contained details that required lunar environment to create. The quality of shadows, the behavior of dust kicked up by astronaut boots in vacuum, the appearance of solar glare on visors, and countless other subtle elements reflected conditions that could not be replicated in studios with 1969 special effects technology. Soviet photographic experts analyzed these images extensively. They had access to photographs from unmanned lunar probes that had landed on the Moon and returned pictures. They could compare Apollo images with their own lunar surface photography, verifying that features appeared consistent across both programs' imagery. The retroreflectors present the most straightforward evidence. Apollo 11, 14, and 15 crews deployed laser-ranging retroreflector arrays on the lunar surface at their landing sites. These devices consist of corner-cube prisms that reflect incoming light directly back toward its source. Scientists on Earth fire laser pulses at specific lunar coordinates, and telescopes detect the returning photons. The time delay between transmission and reception, measured with extraordinary precision, reveals the exact distance to the Moon at that moment. Multiple observatories worldwide have used these retroreflectors continuously since 1969, including Soviet facilities. The Ratan 600 radio telescope observations in 1977 confirmed the retroreflectors existed at the exact locations NASA specified. These physical objects remain on the Moon today, accessible to any nation with appropriate laser-ranging equipment. Their presence proves humans placed them there, since no unmanned mission could have deployed them with the required precision. Soviet scientists understood all of this. They analyzed the data, reviewed the evidence, consulted with experts, and reached the only logical conclusion. Apollo was real. Missions launched from Cape Canaveral, traveled to the Moon, landed on its surface, and returned home successfully. The Soviet government acknowledged this publicly because denying it would have required contradicting their own intelligence services, their own scientists, and their own tracking data. Silence was not an option when every informed observer knew what had happened. Acknowledgement was the only credible response. This technical verification capability extended beyond the Space Transmissions Corps. Soviet scientists working on their own lunar program possessed deep expertise in spacecraft design, orbital mechanics, life support systems, and the countless engineering challenges of human spaceflight. They had attempted to solve these problems themselves. When they examined Apollo, they saw solutions that made technical sense, even when those solutions differed from Soviet approaches. Professional respect existed between engineers on both sides, recognition that difficult problems could be solved multiple ways. This mutual understanding among technical communities provided another layer of verification. American engineers and Soviet engineers both knew what was possible, what was difficult, and what was impossible. Apollo fell into the category of extraordinarily difficult but possible, exactly where genuine achievement belongs. Chapter 4: The Secret Soviet Moon Program, the N-1 Rocket. The Soviet Union was racing to the Moon long before the world knew it. While NASA openly documented every stage of Apollo development, broadcasting failures and successes with equal transparency, the Soviets operated in complete secrecy. Their lunar program, centered on the massive N-1 rocket, represented one of history's most ambitious engineering projects. Its repeated failures and eventual cancellation remained classified for decades. Understanding this hidden program explains why Soviet leadership acknowledged Apollo so readily. They knew reaching the Moon was extraordinarily difficult because they had tried and failed catastrophically. The N-1 rocket's origins trace back to the late 1950s when Sergei Korolev, the legendary Soviet chief designer, began conceptualizing a super-heavy lift vehicle. Korolev had already delivered spectacular successes, including Sputnik and Yuri Gagarin's orbital flight. His vision extended beyond Earth orbit to lunar landings, Mars expeditions, and permanent space stations. Between 1961 and 1963, he received modest funding to begin N-1 development. The rocket was initially proposed as a multipurpose vehicle for military and scientific applications, including delivery of ultra-heavy nuclear weapons. The Tsar Bomba, the largest nuclear device ever tested, was mentioned as potential justification. The military angle helped secure funding, though Korolev's real passion was human exploration of deep space. The design that emerged was staggering in scale. The N-1 stood 105 meters tall, making it comparable to the American Saturn V. Fully fueled, it weighed approximately 2.7 million kilograms. The rocket consisted of 5 stages, each designated by a block letter. Block A, the first stage, represented the most powerful rocket stage ever built. It featured 30 NK-15 rocket engines arranged in 2 concentric circles, producing a combined thrust of 44,000 kilonewtons at liftoff. This cluster of 30 engines became the N-1's defining characteristic and ultimately its fatal weakness. The choice of 30 engines reflected Soviet rocket engine technology limitations. American engineers developed the F-1 engine, producing 7.7 million newtons of thrust, allowing Saturn V to use just 5 F-1 engines on its first stage. Soviet designers could not match this individual engine performance. Their most powerful available engine, the NK-15, generated about 1.5 million newtons of thrust. To achieve the necessary total thrust, they clustered 30 of them together. This created unprecedented complexity. Each engine required its own fuel and oxidizer feed lines, ignition systems, thrust vector control, and monitoring equipment. Coordinating 30 engines to fire simultaneously while maintaining stable thrust and steering required sophisticated control systems that pushed 1960s technology to its limits. Korolev originally envisioned using Earth orbit rendezvous for lunar missions. Multiple Soyuz rocket launches would place components in orbit where crews would assemble them before departing for the Moon. This approach, similar to early American proposals, required rapid launch rates and complex orbital assembly operations. Korolev realized that a more powerful N-1 could accomplish the mission with a single launch, simplifying operations dramatically. He proposed enlarging the rocket's capacity to 92 to 93 tons to low Earth orbit by lightening components, adjusting parking orbit parameters, and increasing first-stage engines from 24 to 30. This change enabled a direct single-launch profile, but increased the first stage's already daunting complexity. Nikita Khrushchev, the Soviet premier, formally authorized the lunar landing program on August 3, 1964. This decision came more than 3 years after President Kennedy's lunar commitment, reflecting internal Soviet debates and competing priorities. Multiple design bureaus proposed different approaches, creating bureaucratic competition that divided resources and attention. Vladimir Chelomey, Korolev's rival who employed Khrushchev's son, advocated for circumlunar missions using the Ur-500K rocket, later renamed Proton. Chelomey also proposed the Ur-700 rocket and LK-700 lunar lander as alternatives to Korolev's approach. Mikhail Yangel's bureau developed yet another competing booster design. This fragmentation of effort weakened the overall program, contrasting sharply with NASA's unified approach under clear central authority. Korolev's unexpected death on January 14, 1966, dealt a devastating blow to Soviet lunar ambitions. He died during routine surgery, a victim of surgical complications and medical incompetence. Korolev had been the Soviet space program's driving force, possessing unique combinations of technical brilliance, political skill, and charismatic leadership. His deputy, Vasily Mishin, succeeded him but lacked Korolev's authority and vision. Under Mishin's leadership, the N-1 program struggled with technical problems, schedule delays, and insufficient resources. The competing design bureaus continued their rivalry without Korolev's ability to impose coordination and priority. The N-1's development suffered from a critical decision that would prove fatal. Soviet leadership refused to authorize full-scale static testing of the first stage. Static tests involve mounting a rocket stage on a test stand, firing all engines at full power, and measuring performance while the stage remains stationary. These tests identify problems with engine coordination, fuel flow, vibration, and countless other issues before risking actual flight. American engineers conducted exhaustive static testing of Saturn V stages, catching and fixing numerous problems that would have caused flight failures. The N-1 first stage, with its unprecedented cluster of 30 engines, desperately needed similar testing to reveal coordination issues and plumbing problems. Why did Soviet leadership refuse to build a static test facility? The infrastructure required for testing such a massive stage would have been enormously expensive and time-consuming. Soviet officials, aware they were falling behind Apollo, prioritized getting hardware to the launch pad quickly over thorough ground testing. This decision reflected broader Soviet engineering culture, where schedule pressures often overrode comprehensive testing. The consequences would be catastrophic. The first N-1 launch attempt occurred on February 21, 1969, from the Baikonur Cosmodrome in Kazakhstan. Designated 3L, the vehicle carried a simplified payload without a lunar lander. Liftoff appeared successful initially. The 31st stage engines ignited, and the massive rocket began rising from the pad. 68.7 seconds into flight, a fire erupted in the engine compartment. A high-frequency vibration had caused a fuel line to rupture, spraying kerosene into the compartment where it ignited. The cord automated control system detected thrust imbalances and began shutting down engines. Within seconds, all 30 engines shut down simultaneously. The rocket, now a powerless ballistic projectile, arced over and crashed approximately 52 kilometers from the launch site. The entire flight lasted 110 seconds. Debris scattered across the Kazakh steppe, and any hope of beating Apollo 11 evaporated. The investigation revealed the fuel line failure, but could not determine the underlying vibration source without static test data. Engineers implemented fixes based on educated guesses, and preparations began for a second launch attempt. 4 months later, on July 3, 1969, the Soviets tried again with vehicle designated 5L. This launch would become infamous as one of history's largest non-nuclear explosions. Liftoff occurred at 11:18 p.m. Moscow time, just 16 days before Apollo 11's launch. For 12 seconds, 5L rose successfully. Then engine number 8's oxidizer pump ingested a piece of debris, a bolt left behind during assembly. The pump exploded instantly, triggering a catastrophic chain reaction. Shrapnel from engine 8 damaged adjacent engines. The cord system detected the failure and shut down all engines immediately at T+15 seconds. The rocket, fully fueled with approximately 2,300 tons of propellant, leaned at a 45-degree angle and dropped back toward the launch pad. The impact and explosion destroyed everything. The blast wave shattered windows 10 kilometers away. Debris flew as far as 10 kilometers from the explosion center. Launch Pad 110 East, which had been built to support N-1 launches, was obliterated. The pad's massive concrete structure cracked and twisted. Metal fragments embedded themselves in surrounding buildings. The launch escape system, designed to pull the Zond spacecraft capsule to safety, performed perfectly. It detected the engine shutdown and fired at T+15 seconds, carrying the capsule 2 kilometers away where it landed safely. But the rocket and pad were total losses. The July 3rd explosion occurred just 13 days before Apollo 11 launched from Cape Canaveral. Soviet engineers and officials watched their lunar program literally explode while America prepared to attempt landing. The psychological impact was profound. Any remaining hope of beating Apollo disappeared in that fireball. When Armstrong stepped onto the lunar surface 17 days later, Soviet space officials knew their program had failed not because they lacked courage or vision, but because the engineering challenges had proven insurmountable with available resources and technology. A third N-1 launch attempt came on June 27, 1971, nearly 2 years after the second disaster. Vehicle 6L incorporated numerous improvements based on failure investigations. This launch proceeded further than previous attempts, with the first stage firing for 51 seconds before failures began. The rocket achieved an altitude of about 40,000 meters and began approaching supersonic speeds. Then the cord control system malfunctioned, commanding roll maneuvers that exceeded the rocket's stability limits. The vehicle began tumbling. Engines shut down automatically. 6L broke apart in midair and crashed 120 kilometers downrange. No explosion occurred on impact because most propellant had been consumed, but the mission was another complete failure. The fourth and final N-1 launch took place on November 23, 1972. Vehicle 7L was the most refined version yet, incorporating lessons from all previous failures. It launched successfully and flew for 107 seconds, surpassing all previous attempts. The first stage performed nearly flawlessly until just before scheduled separation. At T+107 seconds, a rupture in a fuel line leading to engine 4 caused an explosion. The explosion destroyed adjacent engines. Thrust dropped catastrophically, The vehicle began tumbling and broke apart. 7L crashed 110 kilometers from the launch site. The launch escape system again saved the unmanned capsule, but the core mission failed once more. After 4 consecutive failures across nearly 4 years, Soviet leadership abandoned the N-1 program. The cancellation decision came in 1974, though it remained classified. The remaining N-1 vehicles, already partially assembled, were scrapped. Launch facilities at Baikonur were eventually converted for other purposes. The entire program disappeared into classified archives, hidden from Western intelligence and the Soviet public alike. For years, Western analysts suspected a Soviet lunar program existed but lacked confirmation. Charles Vick, an American analyst, pieced together fragmentary evidence and published analyses suggesting the N-1's existence, but his work was largely dismissed as speculation. The N-1's failures illustrate why reaching the moon was so difficult. The engineering challenges were immense. Coordinating 30 rocket engines, each producing over 1 million newtons of thrust, required control systems beyond 1960s Soviet technology. The vibrations, thrust imbalances, fuel flow dynamics, and countless other variables interacted in complex ways that ground testing should have revealed. Without static testing, each flight became a test flight, and each test ended in catastrophic failure. The Soviets encountered problems that proper testing would have identified and solved before flight. This painful history explains Soviet acknowledgement of Apollo. They understood intimately how difficult lunar missions were because they had attempted the same feat and failed repeatedly. When they tracked Apollo 11 flying successfully to the moon, landing, and returning safely, Soviet engineers recognized genuine achievement. They knew NASA had solved the same problems that had defeated the N-1 program. Denial would have been absurd. The evidence was undeniable, and the technical challenges were known to be real. Their own failures proved the mission's difficulty and simultaneously validated American success. Chapter 5, Lunar 15, The Race Within the Race. 3 days before Apollo 11 launched from Cape Canaveral, the Soviet Union sent its own mission toward the moon. Lunar 15 lifted off on July 13, 1969, atop a Proton rocket from Baikonur Cosmodrome. This was no coincidence. Lunar 15 represented the Soviet Union's last desperate attempt to salvage propaganda victory from the jaws of defeat. If they could not put cosmonauts on the moon first, perhaps they could return lunar samples before Apollo 11's crew brought theirs home. The mission's timing, trajectory, and eventual fate provide compelling evidence that the Soviets acknowledged Apollo's genuine lunar mission even as they competed against it. Lunar 15 was part of the Yi-85 series, automated spacecraft designed to land on the moon, collect soil samples using a drilling mechanism, and return the samples to Earth without human presence. The concept was elegant and technically ambitious. A multi-stage spacecraft would land on the lunar surface, deploy a sample collection arm with a drill capable of penetrating up to 35 centimeters below the surface, transfer collected material into a small return capsule, and launch that capsule directly back to Earth. The entire operation would be controlled remotely from ground stations, executed by onboard computers and pre-programmed sequences. Development of these sample return missions began in earnest around 1966 through 1968 as Soviet officials realized the N-1 program could not beat Apollo to a crewed landing. Engineers at Lavochkin Design Bureau, which had taken over robotic lunar missions from Korolov's bureau, worked intensively on the design. The missions offered a face-saving alternative. Even if America landed humans first, an automated sample return would demonstrate Soviet technological sophistication and provide scientifically valuable material. If the timing worked perfectly and Lunar 15 returned samples before Apollo 11 splashed down in the Pacific, Soviet propaganda could emphasize their achievement while downplaying the manned landing. 2 earlier attempts at lunar sample returns had failed. Yi-85 No. 402, launched on June 14, 1969, failed to reach Earth orbit when its Proton rocket malfunctioned during ascent. That mission carried the designation Lunar 15A in some records, though officially it never received a lunar number because it failed to leave Earth. The second attempt was Lunar 15 itself, rushed to the pad for a launch window timed to coincide with Apollo 11's mission profile. The scheduling was not coincidental. Soviet mission planners calculated lunar trajectories to arrive at the Moon around the same time as Apollo, allowing Lunar 15 to attempt its sample return while American astronauts were present in lunar orbit or on the surface. Lunar 15's launch on July 13th put it on course to reach the Moon 4 days before Apollo 11 arrived. The spacecraft functioned normally during its 3-day transit, executing course corrections and preparing systems for lunar operations. On July 17th, Lunar 15 entered lunar orbit successfully, beginning what would become an extended series of orbital adjustments and reconnaissance maneuvers. Soviet controllers faced immediate challenges. The original landing site in Mare Crisium, the Sea of Crises, appeared more rugged than expected based on Earth-based telescopic observations. Radar data from Lunar 15's passes over the target area revealed uneven terrain with slopes and obstacles that threatened landing safety. The same day Lunar 15 achieved lunar orbit, Apollo 11 launched from Cape Canaveral. Soviet tracking stations monitored both missions simultaneously. The Space Transmissions Corps received telemetry from Lunar 15 while intercepting communications from Apollo. Ground controllers in Moscow knew exactly where both spacecraft were at all times. They calculated orbits, predicted positions, and ensured Lunar 15's maneuvers would not interfere with Apollo's trajectory. The two missions would be operating in the same cosmic neighborhood, raising legitimate concerns about potential radio interference or worse, collision risks. Recognizing these concerns, Sir Bernard Lovell at Jodrell Bank Observatory in Britain contacted Soviet authorities through the Royal Society to request information about Lunar 15's orbital parameters. Lovell wanted to ensure British tracking of Apollo would not be confused by Lunar 15's signals, and he wanted NASA to understand that a Soviet spacecraft was operating nearby. The Soviet Academy of Sciences responded through back channels, providing orbital details to Jodrell Bank. This information was relayed to NASA Mission Control in Houston. On July 18, while Apollo 11 coasted toward the Moon, Mission Control informed Neil Armstrong, Michael Collins, and Buzz Aldrin that a Soviet spacecraft was already in lunar orbit. The exchange highlighted the extraordinary nature of the moment. Two Cold War superpowers, locked in intense competition, coordinated to ensure their mission's safety. The Soviets provided orbital data that could reveal Lunar 15's capabilities and limitations. NASA accepted this information and adjusted tracking frequencies to avoid interference. Armstrong acknowledged the information calmly, displaying the professional respect that existed between space programs despite political tensions. Everyone involved understood they were operating at the edge of human capability where mistakes could be fatal. Cooperation on technical matters transcended political rivalry. Lunar 15 spent 4 days in lunar orbit conducting reconnaissance while Apollo 11 approached. The spacecraft executed 52 complete orbits at various inclinations and altitudes, mapping its intended landing site with radar and optical instruments. On July 20th, as Apollo 11's lunar module Eagle separated from the command module and began preparations for landing, Lunar 15 continued orbital operations. Soviet controllers debated whether to proceed with landing given the terrain concerns or delay further. The pressure to attempt landing before Apollo completed its mission was enormous. A delay risked Lunar 15 returning samples after Apollo, eliminating the propaganda value. Ground controllers decided to delay Lunar 15's landing attempt by 18 hours, conducting additional reconnaissance passes to refine navigation data. This delay would prove fatal to any hope of beating Apollo. On July 20th, at 8:17 p.m. GMT, Neil Armstrong piloted Eagle to a landing in the Sea of Tranquility. Michael Collins remained in orbit aboard Columbia, maintaining communications and preparing for the rendezvous after Armstrong and Aldrin completed surface activities. Lunar 15 was orbiting overhead during this entire sequence, its instruments likely detecting Eagle's descent radar and radio transmissions. Soviet telemetry specialists monitoring Luna 15 would have been simultaneously listening to Apollo communications. They heard Armstrong's "The Eagle has landed" announcement in real time, knowing their robotic mission now could only finish second. Armstrong and Aldrin conducted their historic moonwalk during the early morning hours of July 21 GMT. They deployed experiments, collected samples, took photographs, and explored the area around their landing site for 2.5 hours. While they worked on the surface, Luna 15 remained in orbit, awaiting final commands from Moscow for its landing attempt. The juxtaposition was stark. Humans were walking on the moon's surface, while a robotic spacecraft from the competing nation circled overhead, preparing for its own landing. At 3:50 p.m. GMT on July 21st, after completing 86 communication sessions with ground control and 52 orbits, Luna 15 received commands to begin descent. The spacecraft fired its main retrorocket engine to initiate the landing sequence. It descended from orbit toward the rugged terrain of Mare Crisium, approximately 800 kilometers east of the Apollo 11 landing site. For 4 minutes, telemetry flowed back to Earth showing altitude decreasing, velocity dropping, and systems functioning. Then at 3:54 p.m., at a calculated altitude of 3 kilometers, transmissions ceased abruptly. Luna 15 had crashed into the side of a mountain at approximately 130 meters per second. Jodrell Bank tracked Luna 15's descent in real time. Sir Bernard Lovell and his team listened to the telemetry signals, noting the changing frequencies as the spacecraft descended. They heard the commands transmitted from Soviet ground stations. They tracked the signal strength and Doppler shift, indicating increasing velocity toward the surface. When transmissions stopped suddenly, Lovell immediately suspected a crash. He announced this conclusion to assembled reporters who had been following the drama of 2 simultaneous lunar missions. The crash occurred while Armstrong and Aldrin were preparing to launch Eagle's ascent stage to rejoin Collins in orbit. Luna 15's failure meant the Soviets had definitively lost the race for both first landing and first sample return. The mission's failure reflected the immense difficulty of lunar operations. Landing on the moon requires precision navigation, reliable radar, sophisticated guidance systems, and perfectly functioning propulsion. The Soviet automated approach demanded all this plus the added complexity of executing maneuvers without human judgment. Armstrong had manually piloted Eagle to a safe landing site when the automatic guidance system was taking them toward a boulder field. Luna 15's automated systems lacked that flexibility. When confronted with unexpectedly rugged terrain, the spacecraft had no option except to proceed with pre-programmed landing sequences. The crash demonstrated that even highly skilled engineering teams with decades of space experience could fail at lunar landing. The Soviets would not achieve successful automated sample return until Luna 16 in September 1970, more than a year after Apollo 11. What makes Luna 15 crucial to understanding Soviet acknowledgement of Apollo is the mission's existence itself. The Soviets launched an unmanned spacecraft on a lunar sample return mission timed to coincide with Apollo 11. They provided orbital parameters to Western observatories. They coordinated frequencies to avoid interference. They operated their mission in full view of global tracking networks. Every action confirmed they accepted that Apollo was genuinely flying to the moon. If Apollo was fake, if Armstrong and Aldrin were performing in a studio, why would the Soviets launch an expensive automated mission to return samples? Why coordinate to avoid interfering with a hoax? Why time Luna 15's landing attempt to compete with a staged event? The answer is inescapable. Soviet space officials knew Apollo was real because they were doing fundamentally the same thing simultaneously. Both missions involved launching from Earth, traveling to the moon, entering lunar orbit, descending to the surface, and returning to Earth. The technical requirements were identical regardless of whether humans or robots executed them. Soviet engineers understood these requirements intimately because they were solving the same problems. They tracked Apollo throughout its mission with the same instruments they used to control Luna 15. The orbital mechanics, radio frequencies, trajectory parameters, and timing all confirmed both missions were genuine spacecraft operating in real lunar space. Luna 15's crash also reinforced Soviet respect for Apollo's achievement. If their automated spacecraft crashed despite months of preparation, careful planning, and sophisticated engineering, the difficulty of landing humans safely became even more apparent. Armstrong's successful manual landing, after computer alarms and fuel concerns, demonstrated exceptional piloting skill and mission design robustness. Soviet cosmonauts and engineers, who understood these challenges professionally, recognized Apollo 11's landing as a genuine triumph over enormous obstacles. Denying the landing's authenticity would mean denying the reality of challenges they themselves struggled with daily. The Soviet Union would eventually succeed with automated sample returns. Luna 16 landed in Mare Fecunditatis on September 20, 1970, drilled 35 centimeters into the lunar surface, collected 101 grams of material, and successfully returned the sample to Earth. Luna 20 repeated this feat in February 1972, returning 55 grams from the Apollonius Highlands region. Luna 24 achieved the final Soviet sample return in August 1976, bringing back 170 grams from Mare Crisium, near where Luna 15 had crashed 7 years earlier. These successes demonstrated that automated sample return was achievable, validating the original concept. They also confirmed how difficult the task was, with multiple failures preceding each success. The lunar sample return missions provided scientifically valuable material that complemented Apollo samples. Soviet scientists shared some of their lunar material with international researchers, and American scientists shared Apollo samples with Soviet geologists. This scientific exchange continued even during intense Cold War political tensions. The mutual sharing of samples from different lunar locations benefited planetary science globally, advancing understanding of lunar formation, composition, and history. The cooperation on scientific fronts while competing politically illustrated the complex relationship between the space programs. They were rivals, but also members of an exclusive club, the only two nations that had reached another world. Luna 15's place in this history is bittersweet. The mission failed in its immediate objectives, but succeeded in demonstrating Soviet capabilities and intentions. It proved they were genuinely attempting lunar sample return. It showed their tracking and control systems could manage complex deep space operations. It revealed their competitive spirit and determination to achieve something significant even after the N1's failures. Most importantly for our analysis, it provided incontrovertible evidence that Soviet space officials accepted Apollo as a real lunar mission. You do not compete in a race you believe is fake. You do not coordinate orbital parameters with a hoax. Luna 15's existence, timing, and operations confirm that in July 1969, both superpowers were genuinely reaching for the moon. One succeeded with humans aboard. The other crashed trying with an automated probe. Both missions were real. Soviet silence about Apollo being fake was not mysterious. It was acknowledgement of shared reality. Chapter 6: The Propaganda Machine That Stayed Silent. The Soviet Union operated one of history's most powerful propaganda systems. From the early days of the Bolshevik Revolution through the Cold War's height, Soviet information control shaped perceptions across much of the globe. State media reached hundreds of millions of people through newspapers, radio, television, and film. The Communist Party maintained strict control over message content, ensuring all information served state interests. This apparatus actively promoted narratives undermining Western credibility, spreading conspiracy theories about American actions, and emphasizing Soviet achievements while hiding failures. When examining moon landing conspiracy theories, the Soviet propaganda machine's silence becomes the most devastating counterargument. An organization dedicated to discrediting America, equipped with evidence-gathering capabilities spanning the globe, never questioned Apollo's authenticity. Understanding why requires examining how Soviet propaganda operated and what strategic calculations determined their response to Apollo. Soviet propaganda focused heavily on demonstrating the superiority of communism over capitalism. Every achievement of Soviet society was amplified and broadcast globally. Every Western failure was highlighted and analyzed as evidence of capitalism's inherent contradictions. The space program became a premier propaganda tool because achievements in space were visible, dramatic, and easily understood by populations regardless of education level. Yuri Gagarin's flight in April 1961 generated immense propaganda value. The first human in space came from the Soviet Union, from a communist society, proving scientifically and politically that socialism represented humanity's future. Soviet media celebrated Gagarin extensively, presenting him as the product of Soviet education, Soviet values, and Soviet technological superiority. This pattern continued throughout the 1960s. Valentina Tereshkova became the first woman in space in June 1963, another Soviet first that was promoted as evidence of gender equality under communism compared to the male-dominated American program. Alexei Leonov's first spacewalk in March 1965 showed Soviet willingness to take risks and push boundaries. Every Soyuz and Progress launch received coverage emphasizing Soviet space capabilities. When Luna 2 became the first human-made object to impact the Moon in September 1959, Soviet media celebrated for weeks. Luna 9's soft landing in February 1966 was presented as the next great leap in space exploration. Soviet citizens were told repeatedly that their system was winning the space race through scientific excellence and collective effort. The propaganda apparatus also specialized in highlighting American problems. When Apollo 1's crew died in a launch pad fire in January 1967, Soviet media covered the tragedy while subtly emphasizing American recklessness and design flaws. Coverage suggested that American capitalism's profit motive led to corners being cut and safety compromised. When American rockets failed on the pad or exploded after launch, Soviet newsreels showed the disasters as evidence of American technological inferiority. The contrast was clear. Soviet successes demonstrated communist superiority. American failures proved capitalism's bankruptcy. Beyond space, Soviet propaganda promoted conspiracy theories about numerous American actions. The assassination of President John F. Kennedy in November 1963 became a particular focus. Soviet media and intelligence services spread theories suggesting the CIA, FBI, military-industrial complex, or right-wing elements within American government had orchestrated Kennedy's murder. These theories served Soviet interests by suggesting American democracy was a facade, that unelected power structures controlled the nation, and that political violence was endemic to capitalist society. Some of these conspiracy theories were created by Soviet intelligence. Others were amplified from American sources, but all received support and distribution through Soviet propaganda channels. The Vietnam War provided endless material for Soviet propaganda. Coverage emphasized American military aggression, civilian casualties, and the moral bankruptcy of Western imperialism. Soviet media presented the war as proof that capitalism required foreign exploitation and military dominance to survive. Images of napalm strikes, destroyed villages, and civilian suffering were broadcast widely to demonstrate American cruelty. Support for North Vietnam was presented as the Soviet Union defending oppressed peoples against imperialist aggression. The propaganda value was immense, turning global public opinion against American involvement and supporting anti-war movements within the United States itself. Soviet active measures, covert operations designed to influence foreign public opinion and policy, extended beyond conventional propaganda. The KGB, Soviet intelligence services, planted false stories in foreign media, funded sympathetic journalists and publications, and created forged documents implicating American agencies in various crimes. One operation involved forged letters appearing to show American officials discussing racist policies. Another created fabricated evidence of American biological weapons testing. These operations aimed to damage American credibility internationally, turn allied nations against the United States, and support Soviet foreign policy objectives. The sophistication and resources devoted to these operations was substantial, representing strategic intelligence work rather than simple propaganda. Given this extensive apparatus dedicated to undermining American credibility, the absence of any Soviet effort to question the moon landings is extraordinary. If even minimal evidence existed suggesting Apollo was faked, Soviet intelligence would have discovered it, and Soviet propaganda would have exploited it mercilessly. The propaganda value of exposing American fraud would have dwarfed any previous Soviet information operation. Imagine global reaction if Moscow presented evidence proving the moon landings were staged. American credibility would have collapsed instantly. Allied nations would have questioned every aspect of their relationship with the United States. Third world countries courted by both superpowers would have gravitated toward the Soviet Union as the truthful alternative. American domestic politics would have been thrown into chaos with calls for impeachment, criminal prosecutions, and complete government restructuring. The Cold War would have effectively ended with Soviet victory in the ideological struggle. Yet Soviet propaganda did the opposite. They acknowledged Apollo 11's success through official channels. Premier Alexei Kosygin sent a congratulatory telegram to President Richard Nixon that was published in Pravda. The message read in part that the Soviet people shared the joy of the American people on this outstanding achievement. This was not grudging acknowledgement hidden in back pages. This was a front-page official statement from Soviet leadership explicitly celebrating American success. The propaganda value worked against Soviet interests in the short term, but served crucial long-term credibility needs. The Soviet Academy of Sciences issued statements through its president Mstislav Keldysh praising Apollo as a great achievement for all humanity. Keldysh, one of the Soviet Union's most prominent scientists and a key figure in their space program, had no reason to validate American claims if any doubt existed. His statement carried weight within the international scientific community and within Soviet government circles. Soviet cosmonauts added their voices, sending congratulations to Armstrong, Aldrin, and Collins. These professional spacefarers understood the achievement's magnitude and extended respect between those who shared the experience of leaving Earth. Georgy Petrov, a prominent Soviet space scientist, told Western journalists that the landing was a major landmark in human history. Konstantin Fektistov called it an outstanding achievement. These statements came from experts who had dedicated careers to Soviet space efforts, who understood spacecraft systems and mission requirements intimately, and who had no personal incentive to praise American success. Their professional assessments indicated genuine recognition of Apollo's authenticity based on technical knowledge and evidence evaluation. Soviet media coverage continued this pattern through subsequent Apollo missions. Apollo 12's landing in November 1969 received coverage similar to Apollo 11. Soviet television showed footage of astronauts on the surface. Newspapers reported mission milestones. Official statements acknowledged American progress in lunar exploration. Apollo 13's near disaster in April 1970 generated sympathetic Soviet coverage, with offers of assistance if needed for recovery operations. When Apollo 13's crew returned safely after their oxygen tank explosion and dramatic rescue, Soviet media praised the courage and skill that saved the mission. This response contradicts the propaganda machine's usual pattern of highlighting American failures. Instead, they treated Apollo 13 as evidence of American competence and determination. The pattern held through Apollo 14, 15, 16, and 17. Each mission received acknowledgement, coverage, and scientific recognition from Soviet sources. The consistency across 6 successful landings and multiple years indicates genuine acceptance rather than temporary political calculation. If Soviet intelligence had doubts about any aspect of Apollo, those doubts would have surfaced during later missions. The fact that Soviet acknowledgement remained steady through 1972 demonstrates their assessment was based on solid evidence that remained consistent across all missions. What calculation led Soviet leadership to adopt this approach? They faced a choice between short-term propaganda advantage and long-term credibility. Falsely accusing America of fraud without evidence would provide immediate satisfaction to some Soviet audiences, but the accusation would be challenged by independent verification from multiple countries. British tracking at Jodrell Bank, Australian stations supporting NASA, Spanish facilities, and numerous other nations had observed Apollo missions. These countries would contradict Soviet claims. The accusation would unravel quickly, leaving the Soviet Union exposed as liars willing to make false claims for political advantage. This would damage Soviet credibility permanently in ways that far exceeded any temporary propaganda gain. Additionally, Soviet space officials knew the truth. Their tracking data, their scientific analysis, and their own attempts at lunar missions all confirmed Apollo's authenticity. Soviet leadership could not credibly deny this to their own scientists and engineers. The space program employed thousands of highly educated professionals who understood orbital mechanics, spacecraft design, and mission requirements. Telling these experts that Apollo was fake when they had evidence proving otherwise would have undermined internal credibility and damaged morale. The Soviet government depended on these same engineers and scientists to continue advancing Soviet space capabilities. Alienating them with obvious lies would have been strategically foolish. The decision to acknowledge Apollo also reflected a sophisticated understanding of how credibility functions in international relations. Nations engaged in competition still need to maintain reputation for truthfulness in areas where verification is possible. During arms control negotiations, both superpowers depended on mutual verification through national technical means, primarily satellite reconnaissance. These verification systems only worked if both sides trusted that observed data reflected reality. If the Soviet Union gained reputation for denying obvious truths and making false accusations, future arms control agreements would become impossible. American negotiators would not trust Soviet claims about anything. The entire framework of strategic stability depended on both nations accepting objective evidence, even when that evidence was unfavorable. Acknowledging Apollo, despite the political cost, maintained this crucial credibility framework. Soviet propaganda did attempt to minimize Apollo's political significance in subtle ways. Coverage emphasized that space exploration benefited all humanity rather than representing American triumph. Some articles highlighted Soviet automated achievements, suggesting that unmanned missions provided equivalent scientific value without risking human lives. When Luna 16 successfully returned samples in September 1970, Soviet media emphasized this accomplishment while noting its fully automatic nature as evidence of Soviet technological sophistication. These attempts to maintain competitive pride while acknowledging American achievements reveal the psychological difficulty Soviet officials faced. They needed to tell their population the truth about Apollo while preserving belief in Soviet space program competitiveness. The propaganda machine's silence on questioning Apollo's authenticity stands in stark contrast to its aggressive promotion of other conspiracy theories. This selective approach reveals strategic calculation. Soviet intelligence promoted theories that were unprovable or that relied on classified information Americans could not publicly refute. The Kennedy assassination involved complex chains of evidence, Secret Service procedures, and classified intelligence that created ambiguity conspiracy theories could exploit. Vietnam War atrocities involved conflicting witness accounts, classified military operations, and politically charged contexts where truth was contested. These areas offered opportunities for propaganda that would not be immediately disprovable. Apollo offered no such opportunities. The missions occurred in full public view with independent verification from multiple nations. The physics of spaceflight were well understood and could not be faked convincingly. The evidence was overwhelming and accessible to anyone with appropriate technology. Soviet intelligence assessed accurately that attacking Apollo would backfire. Their silence was not mysterious. It was professional competence at evaluating evidence and making strategic choices based on reality rather than wishful thinking. Chapter 7: Cold War Intelligence: What Both Sides Knew. The Cold War created the most sophisticated mutual surveillance system in human history. Both superpowers invested enormous resources in monitoring each other's military capabilities, testing activities, and technological developments. By the late 1960s, satellite reconnaissance, signals intelligence, and human espionage had reached levels of capability that made hiding major military or technological programs nearly impossible. This surveillance framework, originally developed to prevent surprise nuclear attacks and verify arms control agreements, provided both nations with detailed knowledge of space activities. Understanding these intelligence capabilities explains why faking Apollo would have been detected immediately by Soviet systems specifically designed to monitor American space operations. The foundation of Cold War intelligence gathering was satellite reconnaissance. The United States launched its first successful reconnaissance satellite, Corona, in August 1960. This program revolutionized intelligence collection by providing overhead photography of Soviet territory that human agents and aircraft could not safely access. Corona satellites captured images on film, which was then ejected in return capsules and recovered in midair by specially equipped aircraft. The resolution improved rapidly through successive generations. Early Corona images could distinguish objects as small as 12 meters across. By the mid-1960s, resolution had improved to less than 2 meters, allowing analysts to identify individual vehicles, count aircraft on airfields, and measure missile dimensions from space. The Soviet Union developed parallel capabilities. Their Zenit reconnaissance satellites, derived from Vostok spacecraft technology, began operations in April 1962. These satellites photographed American and Allied military installations, tracked naval movements, and monitored strategic weapon deployments. Like Corona, Zenit used film return capsules. The quality of Soviet satellite photography lagged behind American systems initially, but improved steadily throughout the 1960s. By 1969, both nations possessed mature satellite reconnaissance capabilities, providing regular coverage of each other's territory. These reconnaissance satellites monitored space launch facilities continuously. Soviet satellites photographed Cape Canaveral and Vandenberg Air Force Base, tracking construction of launch pads, assembly buildings, and support infrastructure. American satellites monitored the Baikonur Cosmodrome, Plesetsk Cosmodrome, and other Soviet space facilities. Analysts studied satellite imagery to identify new rocket types, estimate capabilities, and track launch preparations. When the massive Saturn V appeared at Cape Canaveral, Soviet analysts photographed it repeatedly from orbit, measuring dimensions and analyzing components. Similarly, American satellites captured images of N-1 rockets at Baikonur, providing CIA analysts with evidence of Soviet lunar program development despite official Soviet secrecy. Signals intelligence complemented satellite reconnaissance. Both nations operated extensive networks of ground stations, intercepting radio communications, radar emissions, and telemetry from missile tests and space launches. The American National Security Agency coordinated signals intelligence collection from stations positioned globally. Facilities in Turkey, Iran, and elsewhere along Soviet borders intercepted communications and telemetry from Soviet missile tests. Similarly, Soviet signals intelligence facilities monitored American communications, tracked radar emissions from early warning systems, and intercepted telemetry from American missile tests and space launches. Telemetry intelligence, abbreviated TLINT, became particularly important for monitoring space and missile programs. When rockets launched, they transmitted continuous streams of data about engine performance, fuel consumption, structural stress, guidance system behavior, and hundreds of other parameters. Engineers on the ground needed this data to evaluate test success and identify problems. The telemetry signals, broadcast by radio, could be intercepted by adversary intelligence services. Both superpowers invested heavily in TLINT capabilities, developing sophisticated receivers and analysis systems to capture and decode telemetry from enemy tests. American TLINT satellites like Rhyolite, launched in June 1970, could intercept Soviet missile telemetry from geosynchronous orbit. Soviet ground stations intercepted American missile and spacecraft telemetry whenever launches occurred within range of their receivers. This telemetry intelligence extended to Apollo missions. Soviet stations intercepted Apollo spacecraft telemetry throughout all mission phases. The data revealed spacecraft performance, crew status, consumables levels, and system health. Soviet analysts could verify that telemetry matched what NASA publicly reported. Discrepancies between telemetry data and official announcements would have indicated deception. The consistency between intercepted data and NASA statements confirmed that missions proceeded as described. Faking telemetry to fool Soviet analysts would have required transmitting false data streams that perfectly matched the expected signatures of spacecraft systems under various conditions across hours or days of continuous operation. The technical challenge of creating such deception would have exceeded the challenge of actually flying the missions. The intelligence framework supporting arms control negotiations formalized these surveillance capabilities. Strategic arms limitation talks began in November 1969, just months after Apollo 11. Both nations recognized that arms control agreements required verification mechanisms ensuring compliance. The concept of national technical means emerged to describe the surveillance systems each nation would use for verification without explicitly naming satellites and signals intelligence programs. Article 12 of the SALT I Agreement, signed in May 1972, codified this principle. It stated that each party shall use national technical means of verification at its disposal in a manner consistent with generally recognized principles of international law. Crucially, it prohibited interference with national technical means and banned deliberate concealment measures that would impede verification. This arms control framework rested on mutual acknowledgement that both sides possessed sophisticated surveillance capabilities. American negotiators knew Soviet satellites photographed American missile silos and bomber bases. Soviet negotiators knew American satellites monitored their strategic forces. The entire verification system depended on both sides accepting that observable evidence reflected reality. If either nation gained reputation for denying obvious truths or making false claims about verifiable matters, the entire arms control structure would collapse. Trust but verify became the guiding principle, with verification provided by national technical means that both sides tacitly acknowledged and agreed not to interfere with. The Apollo program operated within this environment of mutual surveillance. Soviet intelligence monitored every aspect from initial Saturn V testing through final mission recovery. They tracked rocket assemblies arriving at Cape Canaveral by rail and barge. They photographed Saturn V stacking operations in the vehicle assembly building. They monitored communications during countdown and launch. They tracked trajectories with radar. They intercepted radio transmissions throughout missions. They observed recovery operations in the Pacific. This comprehensive surveillance occurred across multiple missions spanning years. Soviet intelligence services accumulated enormous quantities of data about Apollo operations, crew procedures, spacecraft performance, and mission outcomes. The human intelligence component added another layer. Both nations operated extensive spy networks, attempting to recruit sources within each other's governments, militaries, and industries. The KGB and GRU, Soviet intelligence services, targeted American aerospace companies, NASA facilities, and military installations. They sought technical documents, design specifications, and operational procedures. American intelligence services, primarily the CIA, conducted similar operations targeting Soviet aircraft and spacecraft design bureaus, research institutes, and space facilities. While human intelligence rarely provided the comprehensive coverage of technical systems, it offered insights into decision-making, program priorities, and technical challenges. If Apollo was fake, human intelligence sources would have discovered evidence. Thousands of people worked at NASA centers, contractor facilities, and tracking stations. Staging a deception would require participation or deception of this entire workforce. Disgruntled employees, disillusioned engineers, or recruited agents would have reported the fraud to to Soviet intelligence. The absence of any such reports across years of operations indicates that workers genuinely believed they were supporting real lunar missions, because that is exactly what they were doing. Soviet intelligence officers evaluating human source reporting would have found consistent accounts describing actual spacecraft development, real testing programs, and genuine mission operations. This consistency across independent sources confirmed the program's authenticity. Photographic analysis provided additional verification. Soviet analysts studied published photographs from Apollo missions with professional skepticism. They examined lighting, shadows, landscapes, and technical details, searching for evidence of studio photography or special effects. These analysts understood photography professionally, having analyzed millions of reconnaissance images. They knew how lighting behaved in different environments, how shadows revealed sun angles and surface topography, and how camera optics created specific image characteristics. Published Apollo photographs showed features consistent with lunar environment, including airless conditions, low gravity effects, and specific solar illumination. Inconsistencies that would indicate studio photography were absent. Soviet analysts reached professional conclusions that photographs were genuine lunar surface images. The verification framework extended beyond Soviet intelligence. Other nations with space tracking capabilities contributed independent observations. Britain's Jodrell Bank Observatory tracked Apollo missions and shared observations publicly. Australia hosted NASA tracking stations that communicated directly with spacecraft. Spain's Madrid Deep Space Communication Complex provided similar support. These international facilities operated openly with multinational staff. Faking Apollo would require deceiving or corrupting tracking personnel from multiple nations, many of which had no particular loyalty to American Cold War interests. The implausibility of coordinating such deception across sovereign nations with independent space programs argues strongly for authenticity. The intelligence community's assessment processes involved multiple analytical layers. Raw data from satellites, signals intercepts, and human sources went to specialized analysts who evaluated technical content. These technical assessments fed into broader intelligence products synthesized by senior analysts considering all available information. Soviet intelligence produced regular reports on American space capabilities for leadership consumption. These reports would have addressed Apollo's authenticity if any evidence suggested deception. The consistent acknowledgement of Apollo by Soviet leadership indicates their intelligence services reported the missions as genuine based on comprehensive evidence evaluation. Economic intelligence added context to technical surveillance. Soviet analysts tracked American space program budgets, contractor spending, and workforce levels. The Apollo program's cost exceeded $25 billion in 1973, representing enormous economic commitment. This spending was visible in congressional appropriations, company reports, and employment figures. Faking missions while actually spending billions on real hardware makes no economic sense. The scale of genuine investment in Saturn V development, spacecraft manufacturing, and mission infrastructure indicated serious intent to accomplish stated objectives. Soviet economic analysts would have noted this commitment level and factored it into assessments of program authenticity. The architecture of verification rested on redundancy and mutual reinforcement. Satellite photography showed hardware at launch sites. Signals intelligence intercepted communications and telemetry. Human intelligence provided insider perspectives. Photographic analysis evaluated mission imagery. Economic intelligence tracked spending and resources. Each intelligence discipline contributed independent evidence that converged on the same conclusion. When multiple independent sources all indicate the same reality, confidence in that assessment becomes very high. Soviet intelligence analysts following professional methodologies would have reached high confidence assessments that Apollo missions were genuine based on this convergence of evidence. Understanding Cold War intelligence capabilities reveals why Soviet silence about Apollo authenticity is powerful evidence. They possessed the tools, expertise, and motivation to detect deception. Their intelligence services were professional organizations employing skilled analysts and sophisticated technology. If evidence existed suggesting Apollo was fake, they would have found it and Soviet leadership would have exploited it. The absence of such exploitation indicates the absence of supporting evidence. Soviet acknowledgement reflected professional intelligence assessment based on comprehensive surveillance data showing Apollo was exactly what NASA claimed. The implications extend to modern conspiracy theories. Claims that Apollo was faked must explain why Soviet intelligence failed to detect the deception despite having every capability and motivation to do so. The only explanations conspiracy theorists offer involve Soviet complicity or incompetence. Both are historically absurd. Soviet intelligence was neither incompetent nor complicit. They were professional adversaries conducting comprehensive surveillance of American space activities using sophisticated technical means. Their silence on Apollo authenticity was not mysterious or suspicious. It was professional acknowledgement of verified reality. Chapter 8: The Technology That Could Not Be Faked. Apollo missions generated technical evidence that 1969 technology could not fake convincingly. The physics of spaceflight, the characteristics of radio transmission from lunar distance, the properties of lunar samples, and the limitations of television and special effects technology all constrained what deception could achieve. Understanding these technical factors explains why faking Apollo would have been more difficult than actually flying to the moon. Soviet technical experts analyzing Apollo evidence understood these constraints intimately because they worked within the same physical laws and technological limitations. Communications from Apollo spacecraft provided the most fundamental unfakeable evidence. The missions transmitted continuously on S-band frequencies around 2.2 GHz. These transmissions originated from spacecraft antennas and traveled through space to receiving stations on Earth. The physics of radio wave propagation created specific characteristics that revealed transmission origin. Time delay between transmission and reception provided direct measurement of distance. Radio waves travel at light speed, approximately 300,000 kilometers per second. Signals from the moon required about 1.3 seconds to reach Earth, creating a round-trip delay of 2.6 seconds for any exchange between spacecraft and ground control. This delay was audible in communications, with astronauts pausing after ground controllers spoke before responding. Faking this delay from Earth-based transmitters would require introducing artificial delays matching lunar distance precisely. The delays would need to change continuously as spacecraft moved through different orbital positions relative to Earth. During translunar coast, distance increased steadily from Earth toward the moon, requiring delay to increase accordingly. During lunar orbit, distance varied as spacecraft moved around the moon's far side and back. During landing and surface operations, delay remained constant at lunar distance. During return to Earth, delay decreased steadily. Replicating these changing delays while maintaining perfect synchronization between multiple communication channels would require real-time calculation and signal processing beyond 1969 capabilities. Doppler shift provided additional unfakeable evidence. When a radio source moves relative to an observer, the received frequency differs from transmitted frequency by an amount proportional to velocity. Spacecraft approaching Earth showed frequency increase. Spacecraft receding showed frequency decrease. The Doppler shift from Apollo missions matched orbital mechanics predictions precisely. Soviet tracking stations measured these frequency shifts continuously, calculating spacecraft velocities from Doppler data. The velocity profiles matched what gravitational physics predicted for lunar trajectories. Faking Doppler shifts would require transmitting from platforms moving at precisely calculated velocities, matching Apollo trajectory profiles. No Earth-based platform could replicate these motion patterns across multiple days of continuous transmission. Signal strength variations added another layer of verification. Radio signal strength decreases with distance following inverse square law. Doubling distance reduces signal strength to 1/4. As Apollo spacecraft traveled from Earth to Moon, signal strength decreased predictably. Soviet receivers measured signal strength continuously. The measurements matched theoretical predictions for transmission from increasing distances. During lunar orbit, signal strength varied as spacecraft moved behind the Moon, blocking transmissions entirely, then reappeared on the opposite limb. These occultations occurred at times matching orbital predictions based on spacecraft position and Moon's rotation. Faking these patterns would require controlling transmission power and timing with impossible precision. The slow-scan television system used for Apollo 11's landing provided unique evidence. NASA engineers developed a special Apollo lunar television camera operating at 10 frames per second, far slower than standard television's 30 frames per second. This slow frame rate allowed transmission through limited bandwidth available from lunar distance. The camera produced images with distinctive characteristics, including low resolution, high contrast, and specific artifacts from scan conversion. The footage showed continuous motion, including astronauts moving in low gravity, dust kicked up by boots in vacuum, and Earth visible in the lunar sky. The visual characteristics were internally consistent across hours of transmission. Creating fake slow-scan television footage in 1969, studios faced insurmountable obstacles. Standard studio equipment operated at 30 frames per second. Converting to 10 frames per second while maintaining proper motion characteristics would require specialized equipment that did not exist commercially. Slow motion effects were created in film cameras by overcranking, shooting at higher frame rates than playing back at normal speed. But this technique works with film, not 10 frames per second video. The magnetic disc recorders available in 1969 could store only 30 seconds of video for 90 seconds of playback. Apollo television coverage lasted over 2 hours during surface operations. No technology existed to create and store that much slow-motion video matching slow-scan characteristics. The lighting in Apollo photographs showed parallel shadows indicating a distant light source. On Earth, studio lights create diverging shadows because light sources are relatively close to subjects. The Sun, 93 million miles away, creates effectively parallel light rays. Lunar photographs showed this parallel shadow pattern consistently across all images. Additionally, the lighting showed no atmospheric diffusion. On Earth, even in clear conditions, atmosphere scatters light, creating ambient illumination that fills shadows partially. The Moon has no atmosphere. Shadows in lunar photographs were completely black, except where filled by reflected light from nearby surfaces. Creating this lighting in 1969, studios would require a collimated light source mimicking solar parallel rays without any atmospheric diffusion. No such studio lighting system existed. Dust behavior in lunar footage showed vacuum conditions. When astronauts kicked lunar soil, it arced in perfect parabolic trajectories without any air resistance. The dust particles did not billow or float as they would in atmosphere. Each particle followed ballistic path until landing, creating distinctive spray patterns. This behavior is impossible to replicate in atmosphere regardless of camera tricks. Slow motion might simulate low gravity motion, but cannot eliminate air resistance effects on dust. The pristine parabolic trajectories visible in Apollo footage require actual vacuum conditions with lunar gravity. The lunar samples provided the most concrete physical evidence. Apollo missions returned 382 kilograms of moon rocks, soil, and core samples from 6 landing sites. These samples were distributed to laboratories worldwide, including Soviet research institutions. Geologists examined the material using every analytical technique available. The rocks showed properties impossible to replicate with Earth materials. They contained minerals formed in airless conditions. Micrometeorite impacts covering surfaces demonstrated billions of years of exposure to space environment. Isotope ratios differed from Earth rocks, matching predictions for material formed in the early solar system. Solar wind particles were implanted in surface layers, evidence of unshielded exposure to solar radiation. Soviet geologists received lunar samples through scientific exchange programs and analyzed them independently. Their analyses confirmed the material's lunar origin. The rocks could not have been collected from Earth and passed off as lunar samples because their composition, structure, and history were fundamentally different from terrestrial rocks. Creating fake lunar rocks would require technology more advanced than traveling to the moon to collect real ones. The samples included features like shock metamorphism from meteorite impacts, vesicular basalts formed in low-gravity lava flows, and regolith breccias created by micrometeorite bombardment over geological time. No laboratory could fabricate these features convincingly in 1969. The laser-ranging retroreflectors deployed by Apollo 11, 14, and 15 provided permanent verification. These devices consisted of corner-cube prisms that reflect incoming light directly back toward its source, regardless of device orientation. Scientists on Earth fire laser pulses at specific lunar coordinates where retroreflectors were placed. Telescopes detect returning photons milliseconds later. The round-trip travel time reveals Earth-Moon distance with centimeter precision. Multiple observatories worldwide have used these retroreflectors continuously since 1969, including Soviet facilities. The Ratan 600 radio telescope in the Soviet Union measured signals from Apollo lunar surface experiment packages left behind by landing crews. These instrument packages transmitted scientific data continuously for years after astronauts departed, powered by radioisotope thermoelectric generators. Soviet instruments detected these transmissions from the exact locations NASA specified. The packages broadcast at only 20 watts power, requiring sensitive receivers to detect. The fact that Soviet facilities could pinpoint their locations and receive their data confirmed they existed on the lunar surface, where NASA claimed to have deployed them. The Saturn V rocket itself represented technology that could be verified independently. The rocket stood 110 meters tall and was assembled in the Vehicle Assembly Building at Kennedy Space Center. Thousands of workers participated in construction and testing. Journalists, foreign diplomats, and international observers watched launches. The rocket's power output of 34 million newtons at liftoff created light, sound, and vibration impossible to fake. Seismometers detected launches from hundreds of kilometers away. The rocket consumed 2,700 metric tons of propellant in 11 minutes, creating a visible pillar of flame and exhaust that rose into space. Soviet satellites photographed launches from orbit, confirming that massive vehicles actually flew. The spacecraft hardware was equally verifiable. Command modules returned from missions showing heat shield ablation from atmospheric re-entry at 11 kilometers per second. The char patterns on heat shields matched computational models of hyperbolic re-entry from lunar return trajectory. Re-entry from low Earth orbit produces different heating patterns due to lower velocity. The Apollo heat shields showed damage consistent only with high-energy lunar return re-entry. Faking this damage would require subjecting command modules to thermal conditions matching those environments, which would be just as difficult as actually flying to the moon. Trajectory mechanics provided mathematical verification. Apollo missions followed free return trajectories during translunar coast, paths designed so that spacecraft would loop around the moon and return to Earth even without engine burns. These trajectories arise naturally from gravitational physics. The precise timing of maneuvers, orbital insertions, and course corrections all matched predictions from celestial mechanics. Soviet analysts could calculate expected trajectories independently and compare against observed positions. The matches confirmed spacecraft were actually following lunar trajectory paths rather than remaining in Earth orbit or on the ground. The technical evidence accumulated across multiple disciplines all pointed to the same conclusion. Radiophysics confirmed transmissions originated from lunar distances. Television technology limitations made faking the footage impossible with 1969 equipment. Photographs showed lighting and dust behavior requiring lunar environment. Samples possessed properties impossible to fabricate. Retroreflectors remained on the lunar surface, providing ongoing verification. Rocket performance matched theoretical predictions. Spacecraft heat shields showed damage from lunar return re-entry. Trajectory mechanics corresponded to gravitational calculations. Each piece of evidence independently supported authenticity. Together, they created overwhelming technical case that Apollo missions proceeded as described. Soviet technical experts evaluating this evidence reached professional conclusions. They understood the physics involved because they worked within the same scientific framework. They knew what was technically feasible and what was impossible with available technology. They recognized that faking the cumulative technical evidence would require capabilities exceeding those needed to actually fly the missions. Their acknowledgement of Apollo reflected technical competence and honest assessment. Denying obvious technical reality would have made them appear ignorant of basic physics. Soviet scientists and engineers were not ignorant. They were highly skilled professionals who recognized genuine achievement when confronted with comprehensive technical evidence. Chapter 9: The Official Soviet Denial That Never Came. What the Soviet Union actually said about Apollo differs dramatically from what conspiracy theorists claim. Examining official Soviet statements, media coverage, and government positions reveals consistent acknowledgement rather than denial or suspicion. The pattern held across multiple missions, different Soviet leaders, and changing political contexts. Understanding this official record demolishes conspiracy theories that rely on supposed Soviet skepticism. The denial that conspiracy theorists needed never materialized because Soviet officials, scientists, and journalists recognized Apollo's authenticity based on evidence they observed directly. The first official Soviet response came while Apollo 11 was still in flight. On July 20, 1969, TASS news agency, the Soviet Union's official state news service, issued a statement about the impending lunar landing. The statement was brief but significant. TASS reported that the Apollo 11 lunar module had separated from the command module and was preparing to attempt a landing on the moon. This acknowledgement, issued hours before the landing occurred, indicated that Soviet tracking systems were monitoring the mission in real time and that officials accepted NASA's mission profile as genuine. The statement established the pattern that would continue throughout Apollo missions. After Armstrong and Aldrin successfully landed, Soviet acknowledgement intensified. Premier Alexei Kosygin sent a congratulatory telegram to President Nixon that read in part that the Soviet government and the Soviet people share the joy of the people of the United States and the families of the brave astronauts. The telegram continued by noting that this outstanding achievement in the exploration of space is a new achievement of the human genius. This message came from the Soviet Union's head of government, carrying full official weight. Kosygin's reference to the achievement as outstanding and his praise for the astronauts' bravery indicated genuine respect rather than forced diplomatic courtesy. The telegram was published in Pravda, ensuring Soviet citizens read their premier's acknowledgement. This public dissemination prevented any later attempt to deny or reinterpret the statement. Kosygin had committed the Soviet government to recognizing Apollo as a genuine human achievement in the most visible way possible. For conspiracy theorists, this creates an impossible problem. They must explain why the Soviet premier publicly praised what they claim was fraud. The only explanations involve suggesting Kosygin was fooled or complicit, neither of which withstands scrutiny. Kosygin had full access to Soviet intelligence, tracking data, and scientific analysis. If any evidence suggested Apollo was fake, his intelligence services would have reported it, and his statement would have been dramatically different. The Soviet Academy of Sciences added scientific authority to official acknowledgement. President Mstislav Keldysh released a statement calling the landing a remarkable achievement. Keldysh was not a propagandist or politician. He was one of the Soviet Union's leading mathematicians, a key architect of Soviet space program, and a scientist of international reputation. His assessment carried weight within the global scientific community. Keldysh understood orbital mechanics, spacecraft design, and lunar mission requirements at expert levels. His public praise indicated professional evaluation that Apollo had accomplished stated objectives. Scientific institutions worldwide noted Keldysh's acknowledgement, recognizing it as validation from a knowledgeable competitor. Soviet cosmonauts joined the acknowledgement chorus. These were men who had flown in space themselves, who understood the risks and challenges of spaceflight intimately, and who competed directly with American astronauts. They sent congratulatory messages to Armstrong, Aldrin, and Collins, expressing professional respect. Alexei Leonov, who had performed the first spacewalk in March 1965, later spoke extensively about Apollo missions in interviews and memoirs. He never questioned their authenticity, instead discussing technical details with admiration for specific accomplishments. Leonov's perspective as someone who had experienced space environment personally added credibility to his acknowledgement. Soviet media coverage maintained consistent acknowledgement across all 6 Apollo landing missions. Apollo 12, in November 1969, received similar treatment as Apollo 11 with news reports, official statements, and television coverage. When Apollo 13 suffered an oxygen tank explosion in April 1970, Soviet media covered the crisis sympathetically. They reported the crew's struggle to survive and praised the successful return. Soviet space officials offered assistance if needed for recovery operations, though American capabilities proved sufficient. This sympathetic response to American crisis was unusual for Cold War propaganda relationships and indicated that human spaceflight was recognized as a shared human endeavor transcending political competition. Apollo 14's mission in January through February 1971 received acknowledgement, noting Alan Shepard's return to space 10 years after becoming the first American in space. Soviet coverage highlighted this continuity in American space program and noted successful landing despite technical challenges during approach. Apollo 15 in July through August 1971 received particular attention because it carried the first lunar rover and demonstrated extended surface operations. Soviet reports discussed the scientific value of rover capability for exploring larger areas. This analysis of mission capabilities indicated that Soviet observers were following missions closely and evaluating their technical significance seriously. Apollo 16 in April 1972 and Apollo 17 in December 1972 both received standard acknowledgement patterns. By the 6th landing, the novelty had worn off, but official Soviet positions never wavered from acknowledgement. The consistency across 3 years and 6 missions demonstrated that Soviet acknowledgement was not temporary political calculation, but sustained assessment based on ongoing verification of each mission's authenticity. If Soviet intelligence had detected anything suspicious in earlier missions, their coverage of later missions would have changed tone. The unchanged acknowledgement indicated unchanged confidence in mission's genuineness. The Soviet strategy shifted during this period toward denying their own lunar program rather than questioning Apollo. For years, Soviet officials maintained that they had never attempted to send cosmonauts to the moon. They claimed their focus had always been on robotic exploration and space stations. This deception aimed to minimize embarrassment about N1 failures and competitive defeat. Walter Cronkite, the influential American television journalist, reported in the early 1970s that the Soviets had never been in the moon race, echoing Soviet propaganda successfully. This false narrative persisted for decades until post-Soviet revelations exposed the N1 program's existence and failures. The choice to deny their own program rather than question Apollo's authenticity reveals Soviet strategic thinking. Admitting they had tried and failed was embarrassing but credible. Claiming Apollo was fake without evidence would have been devastating to Soviet credibility when the fraud was exposed. Soviet leaders chose the less damaging option. They acknowledged American success while hiding their own failures, maintaining credibility in areas where verification was possible, even while concealing information where secrecy could be maintained. This nuanced approach demonstrated sophisticated understanding of information strategy in the verification age. American intelligence analyst Charles Vick spent years piecing together evidence of the N1 program from fragmentary information. He published analyses suggesting Soviet lunar program existence based on occasional leaked photographs, defector accounts, and logical inference from known Soviet capabilities. His work was largely dismissed or ignored in Western media until the 1990s, when post-Soviet revelations confirmed his analyses were substantially correct. Vic's lonely advocacy demonstrated how effectively the Soviets concealed their lunar program's existence while simultaneously acknowledging Apollo. They controlled information about their own activities while accepting verifiable information about American activities. The post-Cold War revelation of N-1 failures explained Soviet acknowledgement patterns retrospectively. When archives opened and former Soviet space officials began speaking freely, the full story emerged. Vasily Mishin, who succeeded Sergei Korolev as chief designer, gave interviews describing how the lunar program dwindled after the Apollo landing. He discussed N-1 failures, design challenges, and resource constraints with candor impossible during Soviet period. Boris Chertok, another veteran Soviet space engineer, published detailed memoirs describing the moon program, including technical decisions, political pressures, and personal experiences. These accounts confirmed that Soviet space officials had always known Apollo was genuine because they were attempting the same goals and understood the difficulties intimately. Modern Russian space agency, Roscosmos, continues acknowledging Apollo's authenticity in official statements. Despite rising conspiracy theories among Russian public, space agency officials maintain professional positions based on evidence and historical record. They cooperate with NASA on International Space Station operations, share technical information under various agreements, and participate in international space community where Apollo's reality is accepted universally by professionals. Roscosmos officials occasionally make public statements explicitly affirming that Americans walked on the moon, countering conspiracy theories spreading in Russian media and social networks. The official Soviet denial that conspiracy theorists require simply never existed. From the first moments of Apollo 11 through subsequent missions and continuing into post-Soviet era, Russian official positions have consistently acknowledged American lunar landings as genuine achievements. This consistency across different governments, multiple leaders, changing political contexts, and decades of time indicates that acknowledgement was based on solid evidence rather than temporary political necessity. Soviet officials acknowledged Apollo because their intelligence services verified it, their scientists confirmed it, and their own experiences attempting similar missions validated it. No official denial came because no evidence supporting denial existed. Truth, verified through comprehensive surveillance and independent analysis, compelled acknowledgement even from America's greatest adversary. Chapter 10: Apollo's Cargo Honoring Soviet Sacrifice. Apollo 11 carried more than scientific instruments and American flags to the lunar surface. Hidden in the personal preference kit, a small pouch containing items the astronauts chose to bring, were 2 Soviet commemorative medals. These medals honored cosmonauts Yuri Gagarin and Vladimir Komarov, both killed in the pursuit of space exploration. The presence of these Soviet medals on an American spacecraft during the height of Cold War competition represents one of history's most powerful gestures of mutual respect between adversaries. Understanding how these medals reached Apollo 11, what they symbolized, and how both nations responded reveals the human dimension behind geopolitical rivalry. Yuri Gagarin became humanity's first space traveler on April 12, 1961, when his Vostok 1 spacecraft completed one orbit of Earth. The flight lasted 108 minutes and transformed Gagarin from an unknown Soviet Air Force pilot into an international celebrity. His achievement shocked the United States, demonstrating Soviet technological capability and providing enormous propaganda victory for the communist system. President Kennedy's commitment to reaching the moon before the decade's end was a direct response to Gagarin's flight. The Soviet cosmonaut represented everything America needed to surpass. Yet Gagarin also transcended political rivalry. His smile, genuine warmth, and humble demeanor made him beloved worldwide. When he toured internationally after his flight, crowds in countries aligned with both superpowers celebrated him. He represented human achievement rather than just Soviet triumph. American astronauts meeting Gagarin at international events found him approachable, and friendly despite political tensions. The space community recognized him as a pioneer whose courage opened a frontier for all humanity. Gagarin died on March 27, 1968, when his MiG-15 UTI training jet crashed northeast of Moscow during a routine flight. He was 34 years old. The circumstances remain partially mysterious even decades later. The official investigation concluded that Gagarin and his flight instructor Vladimir Kosygin had taken evasive action to avoid another aircraft or perhaps a weather balloon, entering a spin from which they could not recover at their low altitude. Conspiracy theories suggested foul play, mechanical sabotage, or classified military activities that caused the crash. Whatever the cause, the Soviet Union and the world lost a historic figure. Gagarin's death devastated the Soviet space program emotionally. He had become more than a cosmonaut. He was a symbol of Soviet achievement, a public face for the entire space effort, and a friend to colleagues who had shared the dangerous early days of human spaceflight. His funeral drew enormous crowds in Moscow. He was cremated, and his ashes were interred in the Kremlin wall necropolis, the highest honor the Soviet state could bestow. Cosmonauts who had trained and flown with him mourned a colleague and pioneer. The loss resonated beyond Soviet borders to the international astronaut community, who recognized that space exploration's dangers transcended national boundaries. Vladimir Komarov's death came under dramatically different circumstances. On April 24, 1967, Komarov piloted Soyuz 1, a new spacecraft design that was experiencing serious technical problems during its maiden flight. Solar panels failed to deploy properly, limiting electrical power. Attitude control systems malfunctioned, making the spacecraft difficult to orient correctly. After 18 hours of struggling with cascading failures, ground controllers decided to abort the mission and bring Komarov home after just 1 day instead of the planned 3-day flight. Komarov executed a successful deorbit burn, and the descent capsule separated normally. The descent appeared to proceed correctly until parachute deployment. The main parachute failed to deploy properly, remaining tangled in its container. Komarov manually activated the backup parachute system, but the backup parachute became entangled with the still partially deployed main parachute. With neither parachute functioning, the capsule plummeted toward the ground at hundreds of kilometers per hour. Komarov, an experienced cosmonaut who had flown on Voskhod 1 in 1964, knew he was going to die. Ground controllers listening to radio communications heard his final moments. He reportedly remained calm, communicating his love for his family. The capsule impacted near Orenburg at tremendous speed. The impact and subsequent fire consumed everything. Komarov's body was so badly damaged that identification required special efforts. His cremated remains were also placed in the Kremlin wall necropolis. Komarov's death exposed serious problems in Soviet spacecraft development. Engineers had identified numerous issues with Soyuz systems before the flight. Political pressure to launch on schedule for the 50th anniversary of the Bolshevik Revolution overrode technical concerns. Komarov himself reportedly knew the spacecraft was not ready, but flew anyway, partly out of duty and partly to prevent his backup pilot and close friend Yuri Gagarin from being assigned the dangerous mission. The tragedy led to a 20-month hiatus in Soviet manned spaceflight, while engineers redesigned systems and implemented safety improvements. The next manned Soyuz flight would not occur until October 1968. These two deaths, occurring within 13 months of each other, profoundly affected the cosmonaut corps and Soviet space program. They also resonated with American astronauts who faced similar risks. Just 3 months before Komarov's fatal flight, the Apollo 1 crew of Gus Grissom, Ed White, and Roger Chaffee had died in a launch pad fire on January 27, 1967. That tragedy resulted from electrical spark igniting flammable materials in the pure oxygen atmosphere of the command module during a ground test. The 3 astronauts were trapped by the inward opening hatch design and died from smoke inhalation within seconds. Like Komarov's death, the Apollo 1 fire led to extensive redesign and safety improvements, requiring more than a year before manned flights could resume. The parallel tragedies created bonds of mutual understanding between astronauts and cosmonauts. They all worked at the frontier of human capability, where mistakes or equipment failures meant death. Political systems might oppose each other, but the risks of spaceflight created shared experience, transcending ideological differences. This recognition led to gestures of respect between the programs. Frank Borman, commander of Apollo 8, traveled to the Soviet Union on a goodwill tour in July 1969, shortly after his historic circumlunar flight the previous December. The trip was officially diplomatic, aimed at improving relations between the superpowers, but it also provided opportunity for personal connections between space programs. During his visit, Borman met with widows of fallen cosmonauts, including Gagarin's widow Valentina and Komarov's widow Valentina. The meetings were private and emotional. The widows presented Borman with commemorative medals that had been awarded posthumously to their husbands. They asked that American astronauts carry the medals as symbols that space exploration united humanity despite political divisions. Borman accepted the medals with appropriate solemnity. He understood their significance. These were not just metal objects, but representations of sacrifice, courage, and the shared dangers all spacefarers faced. When he returned to the United States, he gave the medals to the Apollo 11 crew, who were then preparing for their lunar landing attempt. Neil Armstrong, Buzz Aldrin, and Michael Collins decided to carry the medals to the moon, along with patches and medals commemorating the Apollo 1 crew. The gesture demonstrated that rivalry in the space race did not eliminate respect for those who had paid the ultimate price. President Richard Nixon issued a statement about the decision to carry the medals. His words captured the sentiment. "The two men we hope will set foot on the moon represent all mankind. Their achievement will be the world's achievement. It is fitting, therefore, that the first lunar explorers carry with them some recognition of the sacrifice made by other space pioneers who helped to blaze their trail." Nixon continued, "There is no national boundary to courage." The names of Gagarin and Komarov, of Grissom, White, and Chaffee share the honor we pray will come to Armstrong, Aldrin, and Collins. This presidential statement was remarkable for acknowledging Soviet cosmonauts by name as pioneers whose sacrifice contributed to American achievement. During the height of Cold War competition, with the lunar landing representing the ultimate test of which system was superior, the American president publicly honored Soviet space heroes. The statement indicated sophisticated understanding that space exploration represented human endeavor transcending political competition. It also served diplomatic purposes, signaling to Soviet leadership that America sought cooperative rather than purely antagonistic relationship in space matters. The medals traveled to the moon in the personal preference kit stored in the lunar module. This kit contained items the crew selected for personal significance, including family photographs, small mementos, and symbolic objects. The Soviet medals were placed alongside patches honoring the Apollo 1 crew and gold pins representing astronaut wings. When Armstrong and Aldrin descended to the lunar surface, the medals came with them. During the surface operations, the crew left several items on the moon to reduce weight for the ascent back to orbit. Among these items was a memorial satchel containing the Soviet medals, the Apollo 1 patches, and other commemorative items. Medals remain on the lunar surface today in the Sea of Tranquility. They sit where Armstrong and Aldrin left them 56 years ago, untouched in the airless environment that preserves everything indefinitely. The gesture was private, not announced during the mission or emphasized in media coverage. The crew did not make public statements calling attention to leaving Soviet medals on the moon. They simply did it as personal tribute to fallen colleagues in the dangerous profession of spaceflight. Soviet officials learned about the medals afterward. American diplomats informed Soviet counterparts that the Apollo 11 crew had honored Gagarin and Komarov. The response was grateful acknowledgement. Soviet media did not emphasize the gesture extensively, perhaps because it complicated propaganda narratives about competitive rivalry, but officials privately appreciated the recognition. Cosmonaut widows were informed that their husbands' medals now rested on another world, carried there by astronauts from the competing nation. The emotional impact was profound. Later Apollo missions continued this tradition of honoring fallen spacefarers from both nations. Apollo 15 carried a plaque listing 14 astronauts and cosmonauts who had died in the pursuit of space exploration. Commander Dave Scott placed this memorial on the lunar surface, along with a small aluminum sculpture called Fallen Astronaut created by Belgian artist Paul van Hooijdonk. The names included the Apollo 1 crew, Gagarin, Komarov, and Soviet cosmonauts Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov, who had died in June 1971 during Soyuz 11 re-entry when their capsule depressurized. The memorial demonstrated continuing recognition that space exploration's human cost was shared across national boundaries. The mutual gestures between American and Soviet space programs reflected professional respect that existed alongside political competition. Astronauts and cosmonauts met at international conferences, exchanged technical information through official channels, and maintained personal relationships despite their government's adversarial stance. They recognized each other as members of an extremely exclusive group who had experienced space travel personally. This created bonds that survived political tensions. The Soviet medals on the moon carry deep symbolic meaning for understanding why conspiracy theories fail. If Apollo was fake, why would Soviet cosmonauts' widows give medals to American astronauts? Why would Soviet officials approve this gesture? Why would President Nixon publicly acknowledge Soviet pioneers during America's greatest space triumph? The entire sequence of events makes sense only if both sides recognized Apollo as genuine achievement, requiring courage similar to what Soviet cosmonauts had demonstrated. Honoring the fallen from both nations acknowledged shared reality of space exploration's dangers and shared humanity of those who ventured into space. Conspiracy theorists cannot explain the medals without resorting to absurd scenarios. They must claim the medals were part of elaborate deception to convince Soviet widows and officials that Apollo was real. This requires believing that Soviet leadership allowed their space heroes to be used in American propaganda supporting a fraudulent mission. The scenario collapses under minimal scrutiny. Soviet officials would never cooperate in such deception, and the widows would never participate in dishonoring their husbands' memories. The simpler explanation is obvious. The medals went to the moon because the mission was real. Armstrong and Aldrin genuinely walked on the lunar surface and left tributes to fallen pioneers who had helped make that moment possible. Soviet officials appreciated the gesture because they recognized Apollo's authenticity and respected the acknowledgement of their own space program's achievements and sacrifices. The entire episode reflects the complex reality of Cold War space exploration, where intense competition coexisted with mutual respect among those who understood the difficulties and dangers personally. Chapter 11: The Post-Soviet Revelation. The Soviet Union's collapse in 1991 opened archives, loosened tongues, and revealed secrets maintained for decades. The classified Soviet lunar program, denied publicly for years, emerged in extraordinary detail through memoirs, interviews, declassified documents, and recovered hardware. The revelations confirmed what Western analysts had suspected but could not prove. The Soviet Union had desperately attempted to reach the moon with cosmonauts, had invested enormous resources in the effort, and had failed catastrophically due to technical problems and organizational dysfunction. These post-Soviet revelations provide definitive evidence that Soviet space officials had always known Apollo was genuine because they were attempting the same goals simultaneously. Vasily Mishin, who succeeded Sergei Korolev as chief designer after Korolev's death in January 1966, began speaking openly in the 1990s about experiences and failures previously classified. Mishin had inherited an incredibly difficult situation. Korolev's death deprived the lunar program of its most effective advocate and organizer. The N-1 rocket program was already troubled with design compromises, inadequate funding, and bureaucratic competition from rival design bureaus. Mishin lacked Korolev's political connections and personal authority to overcome these obstacles. In interviews and published accounts, Ms. Hin described how the Soviet lunar program dwindled after the Apollo landing. The first N-1 failure in February 1969 had been devastating, but might have been overcome with adequate resources and time. The second N-1 explosion in July 1969, just weeks before Apollo 11 launched, effectively ended any hope of beating America to a lunar landing. Soviet leadership, recognizing they had lost the race, reduced funding and priority for the lunar program. Ms. Hin and his team continued developing N-1 through third and fourth launch attempts in 1971 and 1972, but political support had evaporated. When both those launches also failed, cancellation became inevitable. Ms. Hin revealed that he had argued for continuing N-1 development despite Apollo's success. He believed the rocket could eventually be perfected and provide the Soviet Union with heavy lift capability for space stations, lunar bases, and Mars missions. His advocacy fell on deaf ears. Soviet leadership saw N-1 as an embarrassing reminder of failure. Valentin Glushko, who became chief designer when Ms. Hin was removed in 1974, actively wanted to cancel N-1 and develop his own super-heavy rocket design. Glushko signed the cancellation order on June 24, 1974, without even convening a formal design council meeting to discuss the decision. He reportedly ordered complete disposal of surviving N-1 hardware and documentation to eliminate evidence of the failed program. Boris Chertok, another veteran Soviet space engineer, published detailed memoirs in the 1990s and 2000s describing the lunar program from insider perspective. Chertok had worked closely with both Korolev and Ms. Hin on numerous projects. His memoirs provided extraordinary detail about design decisions, political pressures, and personal experiences during the space race. He described how engineers knew the N-1 program was troubled but felt unable to challenge design choices or demand adequate resources. The political environment prioritized meeting schedules over thorough testing, leading directly to the catastrophic failures. Chertok also described the day Apollo 11 landed. He and colleagues gathered to monitor Soviet tracking stations' reports about the American mission. They listened to intercepted communications between Armstrong, Aldrin, and Houston. They followed the landing in real time through independent Soviet observations. When Eagle touched down successfully, Chertok felt admiration mixed with disappointment. As an engineer, he appreciated the technical achievement. As a Soviet patriot, he mourned the competitive loss. His account makes clear that no one in Soviet space leadership doubted Apollo's authenticity. They watched it happen with their own tracking systems. Declassified documents from Soviet space program archives confirmed the N-1 program's scope and problems. Transcripts of meetings between space industry engineers and government ministers showed officials debating whether to continue lunar efforts after Apollo 11. Minister of General Engineering Sergei Afanasyev worried about damaging Soviet reputation with additional failures. Chief Engineer Georgy Babakin of the Lavochkin Design Bureau argued they should continue because automated sample return missions had scientific value regardless of whether they occurred before or after Apollo. These discussions, preserved in official transcripts, demonstrate that Soviet officials fully accepted Apollo's reality. They debated how to respond to American success, not whether the success was genuine. One particularly revealing transcript from June 1969 captured Afanasyev's concerns about the Luna 15 mission. He worried what would happen if Apollo 11 landed successfully and Luna 15 failed. He asked what would happen if the Americans landed on the moon and sent over the soil samples before Luna 15 could attempt its sample return. The phrasing indicated complete acceptance that Apollo would genuinely land and collect samples. The concern was purely about Soviet mission success, not about whether Apollo was real. Afanasyev even worried that if Luna 15 landed but malfunctioned and started gathering moon atmosphere instead of soil, it would be an embarrassment. These private discussions show Soviet officials accepting Apollo as genuine while worrying about their own program's performance. The declassified documents also revealed the extent of Soviet intelligence on Apollo. Reports showed that Soviet analysts tracked every aspect of American space program development. They knew Saturn V capabilities based on satellite reconnaissance, signals intelligence, and occasional human source reporting. They understood Apollo spacecraft design from technical publications and observation. They monitored mission progress with comprehensive tracking systems. The intelligence assessments consistently reported Apollo as genuine lunar program proceeding according to NASA announcements. No classified Soviet intelligence documents suggested Apollo was fraudulent because Soviet intelligence services found no evidence of fraud. Physical evidence emerged when researchers gained access to previously restricted areas around Baikonur Cosmodrome. Remnants of destroyed N-1 rockets littered the steppe despite Glushko's orders for complete disposal. The vehicles were so massive that full destruction proved impractical. Pieces of fuel tanks, engine components, and structural elements were found being used as storage sheds, animal shelters, and construction material by local residents. Photographs of these artifacts circulated in the 1990s, providing Western observers with direct evidence of N-1's existence and massive scale. The hardware confirmed that Soviet lunar program had been real, not merely propaganda or deception. Museums in Russia began displaying recovered N-1 components and memorabilia from the lunar program. The NK-15 rocket engine, centerpiece of N-1's first stage, was exhibited with technical specifications and development history. Models of the LK lunar lander that would have carried cosmonauts to the surface were displayed alongside photographs of cosmonauts who had trained for lunar missions. These public displays marked complete reversal from Soviet-era secrecy. The space program's failures were now acknowledged openly as part of history rather than hidden as embarrassing secrets. Russian space agency Roscosmos inherited Soviet space programs, facilities, personnel, and documentation when the Soviet Union dissolved. Roscosmos officials faced decisions about what information to declassify and how to present Soviet space history to new generations. They chose transparency, releasing documents and supporting researchers investigating the lunar program. Roscosmos cooperated with international space historians, provided access to archives, and endorsed publication of memoirs and technical analyses. This openness transformed understanding of Soviet space efforts. Roscosmos continues operating as Russia's space agency, cooperating with NASA and other international partners on projects including the International Space Station. This cooperation requires mutual trust and acknowledgement of reality. Roscosmos officials consistently affirm Apollo's authenticity in public statements. When conspiracy theories circulate in Russian media, Roscosmos sometimes issues corrections. The agency's institutional position reflects both historical evidence and current operational reality. They work daily with American counterparts who flew space shuttle missions, who trained on Apollo history, and who maintain technical knowledge spanning decades of human spaceflight. Despite Roscosmos's official position, some gaps remain in Soviet space history. Certain aspects of military space programs remain classified. Some documents were destroyed or lost during the Soviet Union's chaotic final years. Individual testimonies sometimes conflict on specific details, reflecting different personal perspectives or incomplete knowledge. Researchers continue investigating these gaps, but the fundamental narrative is clear. The Soviet Union attempted to land cosmonauts on the Moon, failed due to N-1 rocket problems, and acknowledged American Apollo success because their own tracking and intelligence confirmed it was real. The post-Soviet revelations created fascinating historical irony. During the Cold War, the Soviet Union denied having a lunar landing program, claiming they had always focused on robotic exploration and space stations. This denial was propaganda designed to minimize embarrassment about losing to Apollo. After the Soviet collapse, Russia acknowledged the lunar program's existence and admitted the N-1 failures. Meanwhile, conspiracy theories emerged primarily in Western countries claiming Apollo was fake. Soviet officials had told the truth about Apollo being real while lying about their own program. Western conspiracy theorists believed Soviet lies about not having a moon program while disbelieving the truth about Apollo. Modern Russian officials occasionally make statements that confuse international observers. In 2018, Dmitry Rogozin, then head of Roscosmos, joked when asked about plans for lunar exploration that they intended to fly and verify whether Americans had been to the moon or not. The statement generated headlines suggesting Russian official questioned Apollo. Context revealed it was sarcastic humor rather than serious doubt. Rogozin was mocking conspiracy theorists while simultaneously promoting Russian lunar ambitions. The joke fell flat internationally but reflected frustration with persistent conspiracy theories. In 2023, after Rogozin's dismissal, his successor issued clarifications reaffirming Roscosmos's position that Apollo landings were authentic. The clarifications came after Rogozin made additional ambiguous statements post-employment suggesting doubt about Apollo. Current Roscosmos leadership wanted clear separation from those statements. They emphasized that Russia's space agency position, based on historical evidence and technical analysis, accepts Apollo's reality completely. This institutional position matters more than individual statements because it reflects organizational assessment based on inherited documentation and ongoing cooperation with international partners. The complete post-Soviet revelation of the N-1 program and Soviet lunar efforts provides the final piece of historical evidence. Conspiracy theorists claimed Soviet silence about Apollo proved nothing because perhaps the Soviets never tried to reach the moon themselves. If they lacked lunar capabilities, they could not verify or challenge American claims. This argument collapsed when post-Soviet evidence revealed massive Soviet lunar program running parallel to Apollo. The Soviets were not silent observers. They were active competitors who attempted the same goals, encountered similar challenges, and ultimately failed where Americans succeeded. Their acknowledgement of Apollo came from position of expert knowledge rather than ignorance. Chapter 12: The Modern Russian Paradox. A peculiar reversal has occurred in the decades since Apollo. While Soviet leadership in 1969 immediately acknowledged the moon landings as genuine, significant portions of the modern Russian public have come to doubt them. Opinion polls conducted in the 21st century show rising skepticism about Apollo among Russians, creating a paradox where contemporary citizens question what their predecessors accepted as verified fact. Understanding this shift reveals how conspiracy theories flourish in modern information environments and how declining trust in Western institutions shapes perception of historical events. The Russian Public Opinion Research Center, known as VTSIOM, conducts regular surveys on various topics, including conspiracy theories. In 2018, a VTSIOM poll found that 57% of Russian respondents believed the Apollo 11 landing was fabricated. Only 24% accepted it as genuine. The remaining respondents were unsure or refused to answer. This majority skepticism represented a dramatic shift from official Soviet positions during the actual Apollo era. The poll indicated that belief in moon landing hoax theory was particularly strong among Russians aged 45 and older, precisely the demographic that lived through the Cold War period. By 2020, subsequent VTSIOM polling showed some decline in hoax belief, but skepticism remained substantial. 49% of respondents called the moon landing a government hoax, an 8% decrease from 2018. Meanwhile, those accepting the landing as genuine increased from 24% to 31%. Younger Russians aged 18 to 24 showed more acceptance, with 57% believing the landing actually happened. The generational divide suggests that direct Cold War memory and Soviet-era official acknowledgement influenced older Russians less than contemporary conspiracy narratives influence younger ones. These poll numbers reveal that nearly half of Russians doubt an historical event that Soviet tracking systems verified, Soviet scientists acknowledged, and Soviet government officially recognized. The paradox requires explanation. How did a population whose government accepted Apollo's reality come to reject it in higher proportions than Americans themselves? Surveys in the United States show moon landing hoax belief at approximately 6%, far lower than Russian skepticism. The country that accomplished the landing shows more confidence in its reality than the country whose space program confirmed it through independent observation. Several factors contribute to this reversal. The Soviet Union's collapse and subsequent 1990s chaos created deep disillusionment among Russians about institutions, official narratives, and Western intentions. The economic devastation following Soviet dissolution, combined with perceived Western exploitation of Russian weakness, generated resentment and suspicion toward American claims and achievements. In this environment, questioning Apollo became a form of cultural resistance against perceived Western triumphalism. If the West lied about Russia's weakness or exploited Russia's transition unfairly, perhaps the West lied about other things too, including moon landings. The internet and social media provided platforms for conspiracy theories to spread without the gatekeeping that characterized Soviet-era information control. During the Cold War, Soviet citizens received information through state-controlled media that, despite propaganda biases, acknowledged Apollo. In the post-Soviet internet age, Russians access countless sources promoting conspiracy theories. YouTube videos, social media posts, and conspiracy websites present elaborate arguments claiming Apollo was fake. These sources often appear more engaging than dry historical documentation, using dramatic music, selective editing, and confident assertions to make their case persuasively. Russian television and media personalities have promoted moon landing conspiracy theories, lending them mainstream credibility. Television programs exploring alternative history and conspiracy theories attracted audiences by presenting Apollo hoax claims as serious possibilities rather than fringe theories. Media figures found that conspiracy content generated viewer interest and ratings. Unlike during Soviet era, when media followed government directives to acknowledge Apollo, modern Russian media operates commercially with incentives to produce attention-grabbing content regardless of historical accuracy. Declining trust in Western institutions and increasing Russian nationalism contributed to conspiracy belief. As relations between Russia and Western nations deteriorated over issues including NATO expansion, missile defense, and eventually Ukraine, Russian public opinion turned more skeptical toward anything associated with American achievement or Western narratives. Questioning Apollo became entangled with broader geopolitical grievances. If Americans were adversaries in contemporary conflicts, why should Russians celebrate or even accept American historical achievements? The conspiracy theories provided psychological satisfaction by diminishing American accomplishments. The irony intensifies when considering that modern conspiracy theories often rely on Soviet silence as evidence. Conspiracy theorists ask why the Soviet Union never questioned Apollo if it was fake. They propose increasingly elaborate explanations, including the wheat deal theory, claiming America traded grain shipments for Soviet silence. Russian conspiracy theorists promoting these ideas apparently do not recognize that Soviet official acknowledgement, thoroughly documented in historical records, undermines their entire argument. They accept the conspiracy theory framework developed in Western countries without examining what Soviet officials actually said and did in 1969. Roscosmos officials find themselves in awkward position of contradicting popular opinion in their own country. The space agency's institutional knowledge, historical documentation, and ongoing cooperation with international partners leaves no doubt about Apollo's authenticity. Senior Roscosmos personnel worked with Soviet-era engineers who tracked Apollo missions. They have access to archives containing tracking data, intelligence reports, and technical analyses from the period. The evidence overwhelmingly confirms Apollo was real. Yet when Roscosmos officials make public statements affirming this, they face backlash from conspiracy believers who accuse them of betraying Russian interests or covering up truth. In 2023, controversy erupted when former Roscosmos head Dmitry Rogozin made statements that conspiracy theorists interpreted as questioning Apollo. Rogozin had been dismissed from Roscosmos leadership earlier in the year. Afterward, he made comments suggesting doubt about whether Americans actually walked on the moon. Voice of America and other Western media outlets fact-checked his statements, pointing out that all evidence confirms Apollo's reality and that his suggestions were false. The controversy highlighted how modern information environment allows public figures to promote conspiracy theories that contradict historical evidence without accountability. Current Roscosmos leadership distanced themselves from Rogozin's post-employment statements. They issued clarifications reaffirming that Russia's space agency position, based on comprehensive historical and technical evidence, fully accepts Apollo moon landings as authentic historical events. The clarifications emphasized that Roscosmos speaks for institutional expertise accumulated over decades rather than personal opinions of former officials. Despite these official statements, conspiracy theories continued circulating in Russian media and online spaces. The generational divide in Russian conspiracy belief offers some hope for eventual correction. Younger Russians show higher acceptance of Apollo's reality than older generations. This counterintuitive pattern, where youth who did not experience the Cold War believe Apollo more than their elders who lived through it, suggests that younger Russians access more diverse information sources and are less influenced by post-Soviet resentment toward the West. As this younger generation ages, overall Russian acceptance of Apollo may increase, reversing the current high skepticism. Educational institutions in Russia face challenges addressing moon landing conspiracy theories. Science teachers and historians attempting to teach Apollo as historical fact encounter students who arrive believing conspiracy theories absorbed from internet and family discussions. Educators must devote time to addressing misconceptions rather than simply presenting history. The situation mirrors challenges American teachers face with various conspiracy theories, but the specific dynamic of Russian students doubting an event Soviet government acknowledged adds particular complication. The Russian Orthodox Church and cultural institutions generally have not engaged significantly with moon landing conspiracy theories, leaving the field to conspiracy promoters and occasional Roscosmos clarifications. Unlike some other conspiracy theories that intersect with religious or cultural narratives, moon landing skepticism remains primarily secular phenomenon driven by geopolitical attitudes and generalized distrust rather than religious objections. This suggests potential for correction through better education and improved access to historical documentation. Comparing Russian and American conspiracy belief patterns reveals interesting differences. American moon landing hoax believers are relatively rare, around 6%, and are generally dismissed by mainstream institutions. Russian believers approach 50% and include significant portions of mainstream population. American conspiracists tend to distrust their own government and institutions. Russian conspiracists distrust foreign government while often accepting their own government's contemporary narratives. Both groups share tendency towards selective skepticism, questioning official stories in some areas while accepting official narratives supporting their pre-existing beliefs. The modern Russian paradox ultimately demonstrates how historical memory can be reshaped by contemporary political and social forces. Facts documented thoroughly and accepted widely in one era can be questioned or rejected in later periods when political incentives, information environments, and social attitudes change. The Soviet Union verified Apollo through comprehensive technical means, accepted it officially, and never wavered from that position. Modern Russians increasingly reject this legacy, influenced by factors their Soviet predecessors did not face, including unrestricted internet access, commercial media incentives, nationalist sentiment, and deteriorated relations with the West. The paradox serves as warning about how easily verified historical facts can be obscured by conspiracy theories when conditions favor distrust over evidence. Chapter 13: The Conspiracy Theory That Disproves Itself. Moon landing conspiracy theories contain a fundamental logical flaw that believers rarely acknowledge. For Apollo to be fake, the Soviet Union must have been either fooled by the deception or complicit in maintaining it. Neither scenario withstands scrutiny. The Soviet Union possessed the intelligence capabilities, technical expertise, and political motivation to expose any American fraud. They deployed these capabilities continuously throughout the Apollo program. Their comprehensive surveillance detected no evidence of deception because no deception existed. Understanding why conspiracy theories require impossible Soviet behavior reveals how the theories collapse under their own weight. The basic conspiracy theory claims NASA staged moon landings in television studios using special effects, actors, and pre-recorded footage. Proponents suggest various motivations, including Cold War propaganda needs, desire to justify space program spending, or distraction from Vietnam War failures. The theories propose that rather than actually developing technology to reach the moon, NASA invested in creating convincing footage that fooled the world. This required elaborate deception involving thousands of people across multiple facilities, maintaining absolute secrecy for decades. For this deception to succeed against Soviet intelligence, several impossible conditions must be met simultaneously. First, Soviet tracking stations monitoring Apollo launches must have failed to detect that spacecraft remained in Earth orbit or never left at all. Soviet radar tracked every American launch from the moment rockets cleared their launch pads. Orbital parameters, velocities, and trajectories were calculated in real time. If Apollo spacecraft stayed in low Earth orbit instead of departing for the moon, Soviet tracking would have shown this immediately. The orbital characteristics of Earth orbit versus lunar trajectory are completely different and unmistakable to professional analysts. Conspiracy theories offer no explanation for how Soviet tracking stations somehow missed spacecraft staying in Earth orbit when detecting orbital positions was their primary function. Second, Soviet signals intelligence intercepting Apollo communications must have failed to notice that radio transmissions originated from wrong locations. Radio signals carry specific characteristics revealing their origin point. Time delay between transmission and reception directly measures distance. Doppler shift in frequencies reveals relative velocity between transmitter and receiver. Soviet receivers captured Apollo transmissions continuously throughout missions. If those transmissions came from Earth-based studios instead of spacecraft at lunar distances, the time delays and Doppler patterns would have been completely wrong. Soviet analysts specialized in signals intelligence would have detected discrepancies instantly. Conspiracy theories provide no mechanism for faking these physical radio characteristics convincingly enough to fool professional intelligence analysts using sophisticated equipment. Third, Soviet scientific analysis of lunar samples must have somehow failed to detect that rocks came from Earth rather than the Moon. The Apollo missions returned 382 kilograms of lunar material distributed to laboratories worldwide, including Soviet research institutions. Soviet geologists examined these samples using every analytical technique available. They found minerals formed in airless conditions, micrometeorite impact damage from billions of years of space exposure, isotope ratios different from terrestrial rocks, and solar wind particles implanted in surfaces. Creating fake lunar rocks with these characteristics would require technology that does not exist even today. Conspiracy theorists must explain how Soviet geologists, among the world's best scientists, somehow failed to detect that rocks were terrestrial fakes when their entire professional expertise involved distinguishing rock origins. Fourth, Soviet intelligence human sources within American aerospace industry and NASA must have completely failed to detect or report a deception involving thousands of people. The KGB and GRU actively recruited sources in American aerospace companies, universities, and government facilities. They sought technical information, program details, and insider knowledge. Faking Apollo would require vast numbers of people knowing the truth. Film crews, special effects technicians, studio workers, administrative staff, security personnel, and countless others would need involvement or knowledge. The larger a conspiracy, the more likely someone leaks information deliberately or accidentally. Soviet intelligence services with thousands of agents and sources across decades of operations somehow never received reports about the greatest deception in history occurring in facilities they actively targeted for intelligence collection. The wheat deal conspiracy theory attempts to explain Soviet silence by proposing that America traded grain shipments for Soviet agreement not to expose the hoax. This theory emerged decades after Apollo and appears nowhere in contemporary Soviet or American documents. The 1972 and 1973 grain deals between the United States and Soviet Union were real transactions arising from Soviet crop failures. The Soviets purchased approximately 440 million bushels of wheat and other grains worth roughly $700 million. The transactions became controversial in America when grain prices rose sharply, leading to the episode being dubbed the Great Grain Robbery. But these deals occurred 3 years after Apollo 11 and involved open commercial transactions between sovereign governments. The wheat deal theory makes no logical sense. Soviet crop failures causing the need for grain purchases were public knowledge within the Soviet Union. Food shortages affected millions of Soviet citizens who experienced rationing and reduced availability firsthand. These shortages were embarrassing to Soviet leadership, demonstrating agricultural system failures. Accepting grain in exchange for covering up American space fraud would have been exponentially more damaging than simply admitting their space program lost to Apollo. If exposed, the bargain would have shown Soviet leadership betraying their own population's interests for grain, deceiving Soviet citizens about American capabilities, and demonstrating willingness to lie about verifiable facts. The political cost of such exposure would far exceed any benefit from grain imports that could have been purchased through normal commerce anyway. Moreover, the wheat deals involved extensive negotiations, contracts, credit arrangements, and shipping logistics. Hundreds of American grain company representatives, shipping company employees, dock workers, and government officials participated in transactions. Soviet counterparts including trade ministry officials, agricultural ministry representatives, and logistics coordinators were similarly involved. Conspiracy theorists must propose that within these massive commercial transactions, secret side agreements existed whereby Soviet leadership promised silence about Apollo in exchange for grain. This secret agreement would have needed to remain hidden from the hundreds of people involved in actual grain transactions, from intelligence services monitoring Soviet-American relations, from congressional oversight of American agricultural policy, and from historical researchers examining declassified documents decades later. No evidence for such secret agreements has ever emerged despite extensive archival research and numerous memoirs by participants. The timing of wheat deals demolishes the theory's foundation. Apollo 11 landed in July 1969. Soviet acknowledgement came immediately through official statements, media coverage, and scientific recognition. The major grain purchases occurred in 1972 through 1973, 3 to 4 years after Apollo missions had already been acknowledged. If silence was purchased with grain, why did Soviets acknowledge Apollo years before receiving grain? The theory requires Soviet leadership to provide acknowledgement in advance based on promises of future grain deliveries, then maintain silence for years until grain finally arrived, all while gambling that Americans would honor secret agreements without any enforcement mechanism. The scenario is absurd. Some conspiracy theorists, confronted with evidence of Soviet acknowledgement, propose even more elaborate scenarios. They suggest the Cold War itself was fabricated, that American and Soviet leadership secretly cooperated throughout the period while staging conflicts to control populations. This mega-conspiracy theory requires believing that Korean War deaths, Vietnam War casualties, proxy wars across multiple continents, nuclear arms races risking civilization's destruction, and decades of political repression were all theater coordinated between secretly allied governments. The theory is historically illiterate and morally offensive to millions who suffered under actual Cold War conflicts and repression. The psychological factors driving conspiracy belief explain why evidence fails to convince believers. Cognitive psychologists studying conspiracy theories have identified several mechanisms. Confirmation bias leads people to interpret ambiguous information as supporting pre-existing beliefs while dismissing contradictory evidence. Conspiracy believers encountering evidence that Apollo was real reinterpret that evidence as part of the cover-up. Soviet acknowledgement becomes proof of complicity rather than proof of authenticity. The more evidence presented, the more elaborate the conspiracy must be to explain the evidence, leading to increasingly complex and implausible theories. Pattern-seeking behavior, adaptive in many contexts, becomes problematic when applied to random or complex events. Humans naturally seek patterns and causal relationships. When confronted with complex historical events, conspiracy theories offer clear patterns and simple explanations. Rather than accepting that Apollo succeeded through enormous effort by thousands of skilled people working within appropriate technology and budget, conspiracy theories propose single causal explanation. The government lied. This simplicity is psychologically satisfying even when factually wrong. Distrust of authority and institutions drives conspiracy belief. People who distrust government generally are more likely to believe government faked moon landings. This distrust often has rational foundations. Governments have lied, conducted unethical experiments, and deceived populations about various matters. The CIA did conduct mind control experiments. The government did conduct syphilis studies on African Americans without informed consent. These genuine conspiracies, when exposed, reinforce belief that governments routinely engage in massive deceptions. The logical error is assuming that because governments sometimes lie, they lie about everything. This leads to inability to distinguish between actual conspiracies and imagined ones. Social identity also reinforces conspiracy belief. People form communities around shared beliefs, including conspiracy theories. These communities provide belonging, shared purpose, and social rewards for members. Questioning the community's core beliefs risks social exclusion. Long-term conspiracy believers develop identity around their beliefs. Admitting they were wrong requires psychological costs, including loss of social connections, admission of years wasted on false beliefs, and embarrassment about being fooled. These costs make changing minds extremely difficult regardless of evidence presented. The moon landing conspiracy theories also appeal to contrarian impulses. Believers see themselves as enlightened skeptics who see through lies that fooled ordinary people. This self-image as independent thinkers who know secret truths provides psychological satisfaction. The irony is that contrarian conspiracy believers actually demonstrate conformity to alternative narrative communities rather than true independent thinking. They reject mainstream scientific consensus, not based on evidence evaluation, but based on identity commitment to being conspiracy believers. Educational background correlates negatively with conspiracy belief, but does not eliminate it. Studies show that people with lower scientific literacy are more likely to believe moon landing hoaxes, but educated people are not immune. Some conspiracy believers have university degrees and professional careers. They demonstrate that intelligence alone does not protect against conspiracy thinking. The crucial factors are scientific literacy, critical thinking skills, and willingness to proportion belief to evidence rather than to desired conclusions. The self-refuting nature of moon landing conspiracy theories becomes clear when examining what they require. The theories need Soviet Union to have been simultaneously sophisticated enough to track American space activities comprehensively, yet incompetent enough to be fooled by fake transmissions. They need Soviet intelligence to have been relentless in exposing Western deceptions, generally yet completely ineffective at detecting the greatest deception specifically. They need thousands of American engineers, technicians, and astronauts to have maintained perfect secrecy for over 50 years, without leaks despite no evidence that large conspiracies can maintain secrecy over long periods. They need lunar samples to be fakes that somehow possess characteristics impossible to create on Earth. They need photographs and footage to be studio productions that nevertheless show lighting, dust behavior, and physics impossible to replicate with 1969 technology. Each requirement is implausible individually. Together, they form impossibly complex web of assumptions that contradict known facts, established physics, historical documentation, and human nature. The theory survives only by ignoring evidence, reinterpreting facts to fit predetermined conclusions, and proposing ever more elaborate explanations for why evidence appears to contradict the theory. At its core, moon landing conspiracy theory is disproven by the very silence it attempts to explain. Soviet silence was not mysterious abstention from exposing fraud. It was professional acknowledgement of verified reality by adversaries who possessed comprehensive means of verification and every motivation to expose deception if it existed. Chapter 14: The Legacy: What Soviet Silence Teaches Us. The Soviet Union's acknowledgement of Apollo missions represents more than historical footnote. It demonstrates how truth can be established even between adversaries through comprehensive verification and mutual recognition of physical reality. Understanding this Cold War lesson offers insights relevant to contemporary challenges, including disinformation, political polarization, and erosion of shared factual basis for public discourse. The story of Soviet silence also illuminates the human dimensions of space exploration, showing how the most intense geopolitical competition coexisted with mutual respect among those who ventured to space's frontier. The verification framework that confirmed Apollo's authenticity rested on adversarial intelligence gathering. Both superpowers maintained extensive surveillance systems specifically designed to monitor each other's military and technological capabilities. These systems existed because trust between adversaries was impossible. The phrase "trust but verify," popularized during arms control negotiations, captured the principle. Agreements required verification through independent observation rather than relying on other sides' claims. This adversarial verification proved more reliable than friendly verification because adversaries had every incentive to detect deceptions or violations. Applied to Apollo, adversarial verification meant Soviet intelligence services deployed their most sophisticated capabilities to monitor American space activities. They were not merely curious observers. They were active competitors seeking any advantage or weakness. If NASA was lying about lunar missions, Soviet intelligence would have detected this and exposed it for enormous strategic gain. The fact that exhaustive Soviet surveillance found nothing but evidence confirming Apollo's authenticity is powerful proof precisely because Soviets were adversaries. They did not want Apollo to be real. They desperately wished to find evidence of fraud. Their acknowledgement came despite preferences rather than because of them, demonstrating how evidence can compel acceptance even when conclusions are unwelcome. This principle applies to modern verification challenges. Climate science, vaccine safety, election integrity, and numerous other contested topics benefit from adversarial verification, where interested parties with opposing incentives examine evidence independently. When competing research teams using different methods reach similar conclusions, confidence in those conclusions increases substantially. When adversaries with incentives to find different results nonetheless confirm the same facts, those facts are robustly established. The Soviet acknowledgement of Apollo demonstrates this principle operating under maximum adversarial conditions. The technological limitations of 1969 television and special effects created constraints that made faking Apollo impossible with available tools. This historical fact offers perspective on modern concerns about artificial intelligence and deepfake technology. Contemporary deepfakes can create convincing but fraudulent videos of people saying things they never said. This capability raises legitimate concerns about truth and verification in the digital age. However, comparing modern deepfakes to hypothetical Apollo fakery reveals important differences. Deepfakes work for short videos but struggle with extended footage, maintaining consistent physics and lighting. They are detectable through forensic analysis by experts with appropriate tools. Most importantly, deepfakes leave digital artifacts and metadata that reveal manipulation. Apollo missions generated continuous transmissions over hours and days, with multiple independent tracking stations confirming transmission origins. The missions left physical evidence, including retroreflectors and experiment packages, still on the lunar surface. Multiple nations observed missions independently. Contemporary deepfake videos lack this comprehensive real-world verification framework. The lesson is that sophisticated verification systems combining technical analysis, independent observation, and physical evidence can establish truth even when deception technology exists. The solution to deepfakes is not despair about truth being unknowable, but rather developing verification frameworks analogous to those that confirmed Apollo. The human story within Cold War competition deserves emphasis. Space exploration required courage from astronauts and cosmonauts who risked their lives flying untested vehicles to hostile environments. The deaths of Gagarin, Komarov, Grissom, White, and Chaffee reminded both sides that space was dangerous regardless of which nation attempted it. The gesture of Apollo 11 carrying Soviet medals to the moon demonstrated that human respect could transcend political rivalry. Soviet and American space professionals maintained communication, shared some technical information through official channels, and recognized each other as members of exclusive community who had experienced space personally. This mutual respect led to cooperation that surprised many observers. The Apollo-Soyuz test project in July 1975 joined American and Soviet spacecraft in orbit for joint operations. Astronauts and cosmonauts trained together, learned each other's languages, and developed compatible docking systems. The project demonstrated that cooperation was possible even as political tensions continued. The legacy extended through subsequent decades, with Soviet and American cooperation on Mir Space Station in the 1990s and International Space Station from 1998 onward. These cooperative programs descended directly from the mutual acknowledgement and professional respect established during Apollo era. The tragedy of the Soviet lunar program adds poignant dimension to this history. Soviet engineers were attempting goals identical to Apollo using different technical approaches. The N-1 rocket failures were not due to incompetence, but to insufficient resources, inadequate testing, and organizational dysfunction. The engineers who designed N-1 were brilliant, dedicated professionals working within constraints beyond their control. When they watched Apollo succeed, while their own program failed catastrophically, the emotions were complex. Professional admiration for technical achievement mixed with personal disappointment and national embarrassment. Yet their acknowledgement of Apollo demonstrated integrity, recognizing genuine accomplishment despite personal cost. Vasily Mishin, Boris Chertok, and other Soviet space veterans who later spoke openly about the lunar program revealed how competition drove both sides to achieve more than either might have accomplished alone. The race to the moon pushed engineering limits, accelerated technology development, and mobilized resources on scales impossible without competitive pressure. While cooperation might seem preferable to competition, the historical record suggests the space race achieved goals that peaceful cooperation alone might not have reached in similar timeframe. The lesson is that competition can be productive when channeled through achievement rather than destruction, and when adversaries maintain respect for truth and capability. The post-Soviet revelations about N-1 and the lunar program changed historical understanding significantly. For decades, Western sources believed Soviet narrative that they never attempted crewed lunar landing. This false history made Apollo seem less impressive by suggesting Soviets were not really trying. When truth emerged in the 1990s that Soviets had desperately attempted to beat Apollo and failed multiple times, the narrative changed. Apollo's achievement became more impressive because succeeding where formidable competitors failed spectacularly demonstrated real accomplishment. The lesson about historical truth is that classified information eventually emerges. Secrets rarely remain secret permanently. Patient historical research combined with archive declassification eventually reveals reality. The modern rise of moon landing conspiracy theories, despite overwhelming evidence, presents challenges for education and public discourse. Why do substantial minorities in multiple countries believe demonstrably false theories? The psychological research discussed earlier provides partial answers. Confirmation bias, pattern seeking, distrust of institutions, social identity, and contrarian impulses all contribute. But addressing conspiracy belief requires more than understanding psychology. It requires rebuilding trust in verification systems and institutions, while acknowledging genuine institutional failures that justified skepticism. Education plays a crucial role in developing skills needed to evaluate evidence critically. Teaching scientific method, statistical reasoning, and epistemology helps people distinguish between reliable and unreliable sources of knowledge. Importantly, education should not demand blind trust in authority, but rather should provide tools for independent evaluation. Students learning about Apollo benefit from examining actual evidence, including lunar samples, photographs, tracking data, and Soviet acknowledgement. This evidence-based approach respects students' intelligence while demonstrating how multiple independent sources of evidence converge on truth. Media literacy has become essential in the digital age, where information sources proliferate without traditional gatekeeping. People need skills to evaluate source credibility, identify logical fallacies, recognize manipulation techniques, and distinguish between evidence and speculation. Moon landing conspiracy theories provide useful case studies for teaching these skills because the contrast between conspiracy claims and established facts is so clear. Students analyzing conspiracy theory arguments can practice identifying unsupported assertions, logical errors, and inconsistencies that characterize pseudoscientific thinking. The role of institutions in maintaining credibility requires attention. NASA, scientific organizations, educational institutions, and media outlets must earn trust through transparency, accuracy, and accountability. When institutions make errors, acknowledging them openly rather than covering up preserves credibility in the long term. The Soviet Union's choice to acknowledge Apollo despite short-term embarrassment demonstrated this principle. Denial would have provided temporary psychological comfort, but would have destroyed credibility when truth emerged. Modern institutions facing analogous choices should remember this lesson. The verification systems that confirmed Apollo remain relevant models. Independent observation by multiple parties with different interests, technical analysis using appropriate expertise, and physical evidence that can be examined repeatedly all contribute to robust verification. Modern challenges, including election integrity, scientific research validity, and international agreement compliance benefit from applying these principles. When verification systems are transparent, technically sound, and independently conducted, they establish facts that even adversaries must acknowledge. The Soviet silence about Apollo ultimately represents triumph of evidence over ideology. Soviet leadership would have preferred Apollo to be fake. They had every ideological, political, and strategic reason to expose American fraud if it existed. Their intelligence services had every capability and motivation to detect deception. Yet they acknowledged Apollo's authenticity because comprehensive evidence left no other credible option. This demonstrates how reality constrains political narrative when verification systems function properly. Truth is not simply what powerful people say. Truth emerges from careful observation, rigorous analysis, and honest acknowledgement of evidence, even when conclusions are unwelcome. The legacy extends to how we understand human achievement. Apollo represented thousands of people working for years to solve extraordinarily difficult problems. Engineers, technicians, administrators, astronauts, and countless support personnel contributed skills and effort. The achievement was collective rather than individual, distributed across multiple organizations and specialties. This collaborative dimension of complex achievement deserves recognition. Modern challenges, including climate change mitigation, pandemic response, and space exploration, require similar collective effort, drawing on diverse expertise. Apollo demonstrates that such efforts can succeed when properly organized and adequately resourced. The story also illuminates limits of political power over physical reality. Soviet leadership could control information within their society, shape public opinion through propaganda, and suppress dissent through state power. But they could not change the fact that American spacecraft flew to the moon. Physical reality operates independently of political ideology. This lesson matters for addressing modern challenges where political tribalism sometimes leads to denial of inconvenient facts. Climate physics, vaccine immunology, and economic principles operate regardless of political preferences. Acknowledging reality remains prerequisite for effective policy even when reality is inconvenient. The international dimension of Apollo deserves final emphasis. While competition was primarily between two superpowers, the achievement represented human capability rather than exclusively American or Soviet capability. The technologies, scientific knowledge, and engineering principles that enabled Apollo belonged to humanity's collective knowledge. Other nations contributed through tracking stations, data sharing, and scientific analysis. The lunar samples distributed worldwide advanced understanding for all humanity. The photographs of Earth from space, showing a small blue sphere without political boundaries, became powerful symbols of human unity transcending national divisions. Future space exploration will likely be more international than Apollo. The International Space Station demonstrates benefits of cooperation. Current plans for lunar bases and eventual Mars missions involve multiple nations and space agencies. The competitive model that drove Apollo has evolved toward a collaborative model that may prove more sustainable for long-duration exploration. Yet competition was not purely negative. It mobilized resources and focused attention in ways that enabled rapid progress. Finding appropriate balance between competition and cooperation remains an ongoing challenge for space policy. The Soviet silence, properly understood, validates truth's power. In an age where information warfare, disinformation campaigns, and conspiracy theories proliferate globally, the Apollo example shows that comprehensive verification by adversarial observers can establish facts definitively. The lesson is neither naive trust nor cynical skepticism, but rather careful verification using appropriate methods. Trust institutions that earn trust through transparency and accuracy. Verify claims through independent evidence. Acknowledge reality even when inconvenient. These principles, demonstrated by Soviet acknowledgement of Apollo, remain essential for functioning democracy and effective governance. If you found this exploration of space history compelling, subscribe to this channel for more deep investigations into the events and achievements that shaped our journey beyond Earth. Hit that like button if you enjoyed this examination of how truth emerged even during humanity's most intense geopolitical rivalry. The story of Soviet silence teaches us that evidence matters, that verification works, and that truth ultimately prevails when observers are willing to acknowledge what they see. These lessons remain as relevant today as they were when humans first walked on another world. Thank you for joining this journey through one of history's most fascinating verification stories. Keep exploring, keep questioning, and keep seeking truth wherever the evidence leads.